Hello everyone, welcome to my course, I guess. So in practice, I don't like to consider that it's a course exactly, because I would just like to share some of my knowledge and researches related to malware development and technology. So my main idea is to make these videos in English to reach as many people as possible, or even though they don't have the best English. So actually, I'm from Brazil, but I'm living in UK in, I don't know, 6 months, something like that. So I apologize for any mistake. So I will be constantly attaching videos in my free time. So I usually make the video when I'm so tired because I have a job, but I will always be updating the content with new interesting things, separating into models. So I'm currently don't have a personal computer, so I don't have so many resources and time to edit the videos and everything else. So really forgive for my poor professionalism. So yeah, I hope everyone enjoy and learn something interesting. So yeah, thank you very much and bye. In this video I'll be talking about Windows on Windows 64-bit. Um, it's an important class, important information before learning or searching for Heaven's Gate, for example. So basically, what is the Windows on Windows, or WOW64? Basically, it's a technology that allow to 64-bit operation systems to run 32-bit programs seamless. So this is done through an emulation layer that ensure some compatibility between these two architectures. So basically, the WoW architecture have the transition. So to understand how it WoW64 works, we need to take a look at how Windows handle the difference between the difference between the 32-bit and the 64-bit. Um, and basically, into a 64-bit system, so the processors can access more memory, so allowing to the system to perform better with more complex tasks. And it's a highlight the advantage to offer 64-bit systems, such a higher hand and or more capacity and enhance more performance into a 32-bit architecture. So on the other hand, you have a limited of 4 gigabytes of memory, so which more restricts performance in more demanding scenarios. So to do this compatibility, basically the WoW64 actually acts like a bridge. So as an emulation layer, translating to 32-bit instructions into 64-bit instructions. So it is allow 32-bit programs to run on 64-bit operation system. And basically, you have a user mode and a kernel mode traditionally. So WoW64 impacted both of these models to ensure that the 32-bit programs run into a 64-bit environment. In user mode, basically, the WoW map the execution of the program into 64-bit memory space. So this ensure it has access to necessary memory and resource. And the kernel is similarly, but we have the drivers and system calls, so ensuring that interaction between a 32-bit programs and 64-bit system queues without any conflict. So on the other hand, you have the register and memory, of course. So basically, a key part of this WoW64 bridge is a register mapping. So basically, when 32-bit program needs a 32-bit register the WOW64 allocates the corresponding space in a 64-bit register, so without interfering in any system functionality. And the architecture in action, so is when you install, for example, a 32-bit program into a 64-bit system, so the WOW64 perform some necessary translations to ensure the application is installed with correct state and run in 32-bit mode without affecting some system integrity. So on the other hand, the WOW64 need to ensure that when running a 32-bit application, the process is managed properly and loading the correct resources, enabling to the system to run both type of programs simultaneously. So you have some benefits, of course, about WOW64. The first one is a compatibility with more legacy software. So the WOW64 allow you to continue using some older softwares on modern systems without to need to rewrite the entire code of the software for 64 bits. And of course the support for the both type of these applications. So basically you have some limitations, of course, so through the WOW64 allow the compatibility between these applications, 32-bit and 64-bit, but it may introduce a small performance overhead, so the system needs to perform some some translations between these two modes. So a little comparison between the 64-bit and 32-bit architecture in terms of your key components. So you have the address bus size. For example, in 64-bit you can address to 264 bytes, so it's 16x bytes of memory directly. But into 32-bit you can address only 4 gigabytes of memory directly to memory, and of course the register size. So when you use a 64-bit register, allowing more faster operation on large data, but into a 32-bit you are limited to the amount of data processed per cycle. So yeah, and of course the run support. So 64-bit support more than 4 gigabytes of RAM. So, and to 32-bit you are limited to only 4 bytes of RAM unless using your physical address extension, which allow you up to 64 gigabytes. So yeah, I will show some how it works, the translation to this bridge, so the WOW happening into your real time. So basically this is a code that you make a system call to allocate virtual memory on my current process, only 4 KB of memory into current process. So basically, can I open to, yep, right here, 32-bit GBG. Search for the main function right here, and search for the call to the system call, probably push WOW and T. No. Get current process. Probably it's right here. So are you going to step into? As you can see, we call the EDX value So step over the code EDX. So if I go into disassembler, we can see a jump operation to row transition. So and it's a for jump using this segment selector. So basically that is, and if I run, you execute, but memory allocated onto Zverse. And on the other hand, we can check, for example, if on the layer, if this process is running on WOW64 layer using the WOW process is WOW64 process function. So I create a wrapper function to check this, and yep, basically this is the WOW64.
Hello guys, welcome to an Heaven's Gate technique class. So basically, Heaven's Gate is a technique used by malwares to execute a 64-bit code within a 32-bit process on Windows system. Basically, this method exploits the ability of x86/64 process to switch between execution modes. So traditionally in malwares, allowing to malicious code to run into less monitored context by security solutions. So this technique is used by malwares to bypass homing monitoring hooks and evading sandbox and make a directly call to native API without triggering any security mechanisms. So the Heaven's Gate technique works as follow on creating a 32-bit process that probably is a Trojan, and a 32-bit process is started on a 64-bit operating system. So by default, the process run on a WOW layer, WOW64 layer. So basically, the Windows on Windows. This class about WOW64 basic probably is already launched on the class. So switching from 32-bit to 64-bit mode, this malicious code executes a special call to switch to 64-bit mode using instructions like a sysret or a for jump. It's a segment selector. I will touch another edge call in the class token with more details. And basically executing malicious code in a 64-bit mode, the malware can call a Windows native API that's not accessible to the normal 32-bit process, so evading some circuit solutions that monitor only WOW64 calls. So I will be using two references that are essentially very similar, and I will show how can explain the code in detail, and also showing how can you create each code from scratch using the inline symbol, make the code more customizable for each functions you want to use or recreate. So I will try to be as technical as possible, but if you have any question, I strongly recommend to that also research the subject to find other reference for this implementation. So, but even though it's difficult to find something good that works related to Heaven's Gate precisely because it's a really advanced technique and difficult to implement. So, well, I'm a very practical and I don't like the PowerPoint presentations. So let's go straight to the code. So, into the code, we'll start with the defines. So the first part I will explain about the x64 structures that will be used in the code. Basically, some defines reference you can find on the rewolf log is really old article, but it works as perfectly. So right here we have some stubs and macros. So I will start talking about this. The first one is the byte literally emission. So we have a couple of defines. that one and that one. This is an image and this is a DB. Essentially, this is the same. It's identically, but this macro generates at compile time a single byte, the value C in the code string. So right here. So it used to manually insert opcodes. Opcodes is a machine language instructions into the source code using the compile inline assemble mechanism. So basically, I will talk more DB, but that one it works eventually to the another one, but serving as an alternative name to make this code more easy to read when you want to emit a byte. So anyway, here we have the stubs to transition modes. So we have a couple of of them, it's a begin and the end. So these stubs are sequence of bytes that implement a bridge stub for the transition mode between 32 bits to 64 bits. So they manipulate the stack and the segment selector to perform a for return. So the begin, basically, you push the CS value. So the value supposedly is a 0x33 onto the stack. Um, and the second one is another call to an next instruction. So pushing the return address, and next we add a 5 to ASP UE at ASP register to adjust the value on the top of the stack. And finally, we read off that basically is a return for perform a for return using the pushed CS value. So this segment selector. And the end, basically, we call start with echo to generate a push of the return address. And the other one, we move from the segment selector to SSP plus 5 register address. So writes the selector with 0x23 to appropriate position on the stack. And finally, adjust the stack to compensate for the used space. And at the final, it's a write off. It's a return for to going back to 32-bit space mode. So basically, this is the stubs. Right here can be stubs with the code selector. But basically do exactly the same thing that this other stubs. So right here we have the defines about associate integers with each register in the 64 architecture. So basically this value will be used to construct some opcodes that be referenced in the register. For example, when we pushing or unpushing a register on the stack. Right here, we have the macro for pushing popping registers. So this macro generates the opcode for pushing a register. So the first byte is a REX prefix. It's calculated as 0x for the H, or with the extra bit if the register is greater than 7, using that operation right here. And the second part is the base opcode for the push. And basically, which is the 0x650 plus the lower 33 bits of this R value. So, and the other one is the similarly is a macro to generate opcode for pop in a register. So again, the RX prefix is constructed in the same way, but the base opcode for the pop is 0x5h plus the lower 3 bits of the register number. And now I will explain how it works this prefix REX. So basically, right here we have a macro to REX. So this macro emits a byte 0x4h with the RX prefix with the W operand size. It's a bit set. So W is a bit set operation, indication the operation with 64-bit operands. So after emitting this prefix, the inline assemble allow two instructions that follow it to be interpreted in line with that prefix. So in 64-bit mode. So the ARIX prefix is extension of 86 instruction set that. So in 64-bit mode, allow to use a 64-bit operands and access to extended registers RH through R50. In essence, it adds a 4 extra bits to the instructions encoding and modifying the way the rest are referenced. So right here we have I talk about the structure. So the EAX byte value in the default structure binary is a 0100 WRXB. So the W1 set to 1 indicate that instruction operates with a 64-bit operand instead of a standard 32-bit. So the R is an extends register. Fields represent the mod byte, allowing to access a register beyond the traditional set for RH through R50, 15. So basically we extend the index field in the scale-based address modes. And the B extend the RM field, which can indicate a register or part of the address. So basically in this macro define Rx with this image in the inline assemble, the value 0x for h is emitted. So in hexadecimal, this value is equivalent as 0, 1, 0, 0, 1, 0, 0, 0 in binary. And the bit W is set 1, so it indicates that the instruction you use a 64-bit operands. So each calls that we made, or each instructions operands we do in the 64-bit layer, space, sorry, we just to pass this macro at the first. So yeah, this approach basically is crucial for the code to be able to manipulate 64-bit register and transition between the execution modes as more transparently. So right here we just have we don't use these conversions, but basically it's a conversion to the word 64. So convert a pointer to 64-bit value, ensuring that conversion is done safely using our long pointer. And the other is convert a handle, which is a pointer or integer, depending on the context, to 64-bit value using a long picture to maintain some architecture compatibility. And right here is a really important is a reg4 or register 64 union is a structure that allows you access the same 8 bytes of memory in 2 different ways. So the first one, we have the ARIX value. So this member used to access or assign a 64-bit integer value. So it represents the full 80 bytes of the variable. And the other one is our ARIX-DW. So this is an array of 2 elements, each with 32 bits, the word, the full. And the 0 index corresponds to 32 least significant bits to low port of the value stored in the ARIX value, and the ARIX DW, the 1 index correspond to 32 bits most significant bits. So basically it's the high port. So for example, if I mix just that one is some AXW a move operation to AX to lower part, so the most or the least significant bits of this value. So it means that the value contained in the AX register, which is a 32-bit long, is being copied to the lower 32 bits of AX value or AX DW0. Okay. So yeah. However, if this 64-bit function return a value that also use the upper 32 bits, both array index will reflect to the full value in our X value. So going to namespace, define it. So this define is already be done, and of course you can see with more details and explore with more details in the source code that will be attached. But first structure is a list entry, but this structure is used to implement a dope list in a 64 environment. It's a common in the intro implementations on the Windows operating system. Second one is the Unicode string 64. Basically represents a Unicode string in the Windows environment, allowing for secure string management through the control of the current size and the capability of allocate to store it. And the process-based information is a really important structure. Basically provides information about the process. Is common usually in such the calls such as anti-prior information process to retrieve essential data about the internal structure of the process, such as the PAB address. That one is a very interesting define because the structure represents a simplified version of the process environment block in the PAB for 64-bit process. So basically, as you know, the PAB is just an internal structure that stores information about the state of the process, include data about load models, initialization parameters, and etc. But in resume, this structure is used to access only the LDR field of the PAB, ignoring all the details that are not necessary for the intent operations such as model enumeration, for example. The next one is a PAB LDR data 64. It's a part of the PAB that store critical data about how the models in the process were loaded and is ready to be used by tools or injection reverse engineering techniques to iterate off the loaded models. So basically, we have the inload order model lists. So these structures represents a double linked list of models loaded in the process. So this list is essential for enumeration and manipulation of DLL and other models, allowing to you traverse and locate specific information such as base address or exported functions about the models. So right here we have the other one as earlier data table entry. So this structure represents an entry in the list of model node or DLL or executable in a process, as mentioned by Windows in the PAB. So in short, this structures aggregates all the information necessary to identify, locate, and interact with a model loading the process. So facilitating the task of enumeration, inspection, and potential manipulation of model in memory. Really useful. Next one is the image export directory. So image export directory structure describe the export table of a model in the Windows PA, so the portable executable formats. So this table contains information about which function or data the model makes available to the other models, such as DLL exporting functions. So in short, these structures allow you to locate which functions are exported, the address, and when available, their names and ordinary arrays. So, yep. Right here is basically the most important. So the DOS header structure is the initial header present in the executable files in the DOS format, and also in the Windows PF files, which start with this header for some compatibility about the architectures. So basically, it serves as the front door for executable files into PF formats. So that field, E or L is a field that is crucial because it points to the NT header that contains update informations about the executable, such as the import, export, resource table, and all the relevant data to running onto the operation system. Right here is the image file header. And this structure, as no of a COF header, contains basic information about the executable file or DLL in the portable executable format. So this provides essential information about PA file, helping the system and analysis to understand how the file should be interpreted and loaded and executable. So the next one is the image data directory. So is structure is essential component of the Windows PF format used to describe specifically directories or table or data within the executable image. In short, the structure tells the system where to find certain sets of information, such as export and import resource table and how much data is available for each of these directories. Right here is the core component, basically the image optional header format for 64-bit images. In short, basically this structure aggregates all the information the operation system needs to prepare the image for execution, for versioning data to memory configuration and pointer to data directories. So right here we have the image entity headers. Is a core of PF file for 64-bit images. So consolidate that data needed by the Windows loader to interpret, map, and execute the image, combining the COF information with detail execution and memory parameters. And basically, this is the last one. Another detail I talk about COF a couple of times, but basically the COF is a stands for a common object file format. It is a standard format for object files and executables widely used in systems such as Windows. A PF file, the COF header is represented by the image file header structure and contains an essential information about the file. So the architecture for which the file was compiled, like 64-bit or x86, the number of sections that's present in the file, such as .text, .data, rc data, etc. Compile time, date and time, and optional header size and flags that define some file characteristics. So basically, that is the class about the defines. And the next one, I will talk about the functions in the second part and explain uh, these functions and how could be used to search for NTDLL model. But yeah, there is. So this is the second part for the Heaven's Gate implementation on the spot. I will talk how can we get the model handle from NTDLL and how to open or search the process by name to open a remote process and get the handle for this process that we use to create a thread on the next lesson. So basically, going back to the defines, I will talk about some functions definers and how it works. At the second part, I will talk about the read memory, the peb address function, and the two functions for native DLL function and native model handle. And the last model handle. So first, we'll talk from read memory function. So that's fine. Yeah, there it is. So basically, a read memory function creates an align buffer to accommodate the type T. So this is a template. So basically, it's a C++ advanced technique to convert some values. So yep, it's a type trait to proceed initialize a data type with the same size and alignment on the memory that T type name requires. So basically, the type is mandatory in the template when we are access type depend member. So the compiler needs to know what type. That type is a type. It's not a value. Makes sense. So second, we call the read memory function. So and we be pass the address, the buffer, and the size of T, size of the template type. So just read the bytes from the memory or wherever for the address and writes them into the buffer. Yeah, and basically we cast the buffer to T pointer and returns a T object by value. So sorry, this is the T object. Yeah, and we have a static cast to convert a buffer address to void pointer. Then static cast convert the void pointer to a T pointer. So in short, it's a helper that reads the size of T bytes from an address and give you a T object by value without you having to create a local buffer for yourself. It's more an abstracted function. So we go into the read memory, something like a more low-level read memory function. So right here we have a type of P. So, but basically we receive a buffer pointer and optionally a size. So there's not a requirement to where the data should be read. And we will call a empty WOW64 read virtual memory. Uh, So which reads the bytes from the remote address or wherever and fill into the buffer. If any errors we occur, yeah, a throw exception was be done. Actually, it's not a throw, but it's just a printf to fail and an exit. So the program should be done and exit the program. So in short, is the lowest level function that reads a raw memory into the buffer without returning anything. So it doesn't worry about creating a buffer, just filtering it. So yeah, basically this is the read memory. Falling to model handle. So basically, I will talk about the model handle, but the first part we will access the PAB model and loading the data. But we call the PAB address to get the PAB address of the PAB function, PAB address function, to get the PAB address of the current process. But we read with read memory, so the PAB64 structure from that address, and from the PAB we will extract the LDR field which points to a structure. So the PAB LDR data 64 responsible for storing information about all loaded models. So going to that address function. Um, this function is pretty simple, but yeah, basically it's intended to obtain the base address of the process invariant block of this currency process. So we use a helper function. There's a native entity function to dynamically obtain the pointer to the native function. So NTO 64 query information process, which is the NTDL library. And we fill into the process information. So in the last class, I will talk about the define. So if you don't remember, just going back and read again. Yep. So we will fill the process information on the structure. So declare structure process basic information 64 and a PBI variable that will store the basic information about the process. So then we call the anti-wall per information process function, passing the handle of the current process to fill in this structure. So yeah, basically if the call is successful, the function will return the PAB address, which is the address of the process PAB. Going to NT-DLL function, basically this template function dynamically obtains the address of the current of the function exported by DLL and TDLL and convert into the function that is specified by the template. So F type in this case, but we use a native model handle. So this is just a helper function. So to get the NT-DLL handle, so this function you get the NT-DLL function. Since the variable is static, so this is done only once time. And we call the get prox address, passing the NT-DLL handle and the name of the function to be obtained. So the result is converted to type F using reinterpreted cast. And we have error checking. If it's a new pointer, print an error message and just terminate the program. But if the function is found, returns the pointer to each and already convert to the desired type, F type. So going to native model handle. Um, yeah, really, really simple. This function retrieves and returns the handle of a model, usually a DLL, loaded in the current process. So um, call basically get model handle A with the name to get a handle of the model whose name is given. If return a handle is a new pointer, or if the model is not loaded, we will print a message error and exit the program. But if the model is found, we return the obtained handle. Um, yep. If you are thinking there's so much complexity in this code about hybrid functions and templates and something like that, remember this is really good work done by some authors like Revolve and another one that sorry, I don't remember, but this is in the description. So I just explain as more technical possible how it works. So, yep, remember. Okay, going back to model handle. Mm, yeah, this function right here. Yeah, so I already explained the first part, but the second one, we will determining the end of the model list. So we get the last entry, but we calculate the sentinel of the final address of the linked list of models. So the link list of models inside the pattern, their data, the store in the field called inload order model list. So by adding the LFDR base with the offset of this field, we can obtain the address that indicates the end of this list cycle. So, yep. The third part, we initializing the list iterator. So uh, basically, we declare a variable head that represents the unknown entry in the list of models and reads the pointer to the first element on the list as a flink field of the linked list, starting to iteration. The first, for part, we just iterating over the loaded models. So enters a do while loop to iterate through each entry in the list. So basically, in each iteration, attempts to read the memory to the next model structure using the heads, inload order, links flink pointer, and updates the head variable. So if an exception we occur, we just, for example, memory rate failure, the iteration is skipped with just continue. So the last is the model name comparison. So the first we have the name length. So how we calculate how many characters make up to name of the current model, dividing the length in bytes by the length of this type, the char t. So right here we make a size check. So if the length really doesn't match the length of the provided model name string, basically we will skip the model and continue to the next one. Yep, right here we will read the name. So and dynamically allocates of array of the char t to store the model name and read the memory from the address pointed by head DLL base DLL name dot buffer where the actual name is stored into this buffer. The last movie comparison. So we use LCD quo with begin model name and the end model name to compare each character of the model name as parameter type of string right here, which the name read converted to the char t. So if the names match, we just return a head for DLL base, which the base address of the model. Um, yeah, and the last actually, and it is a completion of the iteration and error handling. So the loop continues until the link pointer of the current node returns to the last entry. So we indicated that we have traversed the entire circular list of models. So if no model with the specified name found, so the function just throw the error assistant error exception with an error message stating that it's not possible to obtain the model handle. So really, yeah, it's pretty simple. But basically, we just use this function. I will talk about that other ones in the next class. But going back to our main function, and let's start to build the Evans gate. So the first, I need to get the empty model. So I by the auto type and a WOW64 and a model handle with ntdll.dll. And just print of ntdll.dll address, but yes, ntdll. Yep. So basically, if this code you can get to ntdll address 464 bit mode. The other function that we make it's a handle with open process. Oops, process by name. Christ. And we just receive like he can I just make L B C D S G R process name like notepad, for example, X, and we call uh, receiving the handle of this process. This is the intention. E process, for example, E by name, passing the process name. Yep, basically this, and then I make the process name. Really simple. So basically, what does this function need to do is creating first a process a snapshot of all the process using the create2 help 32 snapshot into to help 32 library. And this function creates a snapshot of all process running on the system. We initialize some structure called th32cxsnap process that indicate that we want information about the process. On this function, as I said before, first we need to create a snapshot for our process. So yep, this should be simple. Basically, we need to create a handle with 8 snapshots, passing the create to how 32 snapshots function. Create to Yep. So th32 cs snapshot process. Snap process. That's an H. And basically, we need to verify if the snapshot is an invalid handle and the value. And if it invalid handle value, you just fail to create a snapshot process. And can we exit the program? Basically, it's the first part, and the second one we need to initialize the process entry structure. So the structure should be storing information about each process found in the snapshot, such as the process ID and the executable name. So the size configuration before using this structure, it is necessary to set the DW size field to the size of the structure. So this is important um, so that GAPI knows which version of structure is being used. So it's really simple. We just need to start at proxy entry 32, P33, 32, 32, the DW size equals the size of this structure. Oops. Yep. And now we need to iterate over the process. So we have to use the function process 32 first to start iteration. We get the model for the um, um, first process listed in the snapshot. And if this call fail, we can just print a message error or something ignore. And of course, the loop with the process 32 next in the heads. So we need to make a comparison using some function to compare the string to compare the name of the process executable, like PA dot C SC 32 SC exit file with the process name passed on the function. And if the name match, it mean that we have the desired process. So let's sort. So basically, if the process 32 first, H snapshot, and into this structure. So we do if so, of course, while process 32 next, if H snapshot would be 32. If we don't find, we can just close the handle. So the code should not be run onto this port because basically the process is not found. But closing the snapshot handle and print process not found. Actually, it's the last port, but yeah, there's no problem. So yeah, in the if comparison, we can make the SMP and B PA32 as the file with the process name. If it equals 0, so now we need to go into the other part, is opening the process. So when the process is found, the open process call with the process all access parameter to try to obtain the full remote process access. So in the second part, we just need to um, that second parameter is just a false that indicate we are not entering in the handle, and the third parameter is just a process ID for the current process that we read or comparing. So yeah, create just another handle right here. Um, oops, process, if process our access and false, and pass the P32, P32, the H32 process ID. Pretty simple. And of course, if each process was different new, we can just bring to the open process, open with success. You can return the handle of the process, but close handle if anything works. Eight snapshots and return a zero value. So I think this is the code. And while process 32 next with this function. While yeah, of course. Just get right here. Just an indentation error. So yep, I think that for now it's okay. Oops. You just compile the program and execute. And yep, this is the address for NTDLL, and this is the process open with success status because I already have NTDLL open right here. So can I, if you want to check, you can just open, for example, x64dbg and attach some 64 process like Notepad, for example. And going to the register, you can see the load address for NTDLL. This is correctly address right here. Yep. So basically, that is in this class. So in this class, I will talk about import functions from the NTDLL using a dynamic resolution to obtain the address of the expected functions. So first, I will talk about these functions right here. It's just just four functions that we use to do this. So the first one is the import function. Is the most important function to do this. So basically, this function aims to dynamically obtain the address of an exported function, or in this case, identified by the procedure name. So as a pass as an argument from, but yeah, it's a model whose handle is provided in each model or NT-DLL in this case. So it uses an indirect code to the system function responsible for resolving the address of these exported functions. In this case, I use LDR get procedure address. So the first part is to obtain the LDR procedure address function. So we use a static variable, LDR procedure address base, to store the address from this function. So it's obtained by the tail LDR procedure address function. So I will go to this function to explain a little bit more details what these functions we do. Sorry. So yeah, it's not so simple this function, but yeah, let me explain. Basically, this function is an installed and exported function. In this case, our get procedure address if you into the DLL model and returns your absolute address into memory. So to do this, it pours a model in the export table, reading the array of the function address and names and ordinals. So the first part, basically, is obtaining the base address of NTDLL. So we call the model handle NTDLL, etc. So and the second one, we need to retrieving the exported structure. So basically, the image exporter if the NTDLL base and function reads the model headers, so throw to the PAB and the PA structures and return the image export directory structure. So this structure basically contains some essential information about the model export, such address of functions, RVA of the array, and the address of the exported functions, and address of names and address of ordinals. Often it's RVA of the array and the names of the functions, or in this case, in the name of ordinals, you the array about the ordinals with the index is the array of a function. So um, go to whoops, go to image exportee, and this function basically is really easy. So we need to extract the image exportee structure of the model, or in this case, there's an entity from the base address in the memory. So basically, the first we read to DOS header and obtain the elf final. So reads the image dot structure and the model base address, so the NTLL base. And this value is necessary to locate the image empty headers. So this is a structure. So after this, we need to read into empty header and access the data directory of the export. So to read the NT header structure of this address is basically need to make plus combination with NT del base and LF final. So that is the position where the NT headers begins. So within this structure, access to your optional headers, which contains an array called the data directory. And basically the data directory with the image directory entry export elements correspond to the export directory, and the virtual address field of this directory indicates the offset in relation to NTDLL base where the image export directory structure is located. So yeah, and after this we just make just a compare with the axis of this party table. So if virtual address is 0, basically it means that the model does not have a valid export table. In this case, the function just throws a runtime error in reporting the error. We don't need to crash the program. But if it's okay, we just return the image export directory structure and read the memory from the address and TLL base plus IDD and a virtual address and intercept this block as an image export directory structure. So, and again, this structure basically contains information about our function and symbol exported by the model, the NTDLL. So going back to LDR procedure address. Oh, it was right. Yeah. So third port, it's reading to export table. So we make three read memory operations. The first one is the function address table at RVA. So dynamically allocates an array of unsigned long if its size is equal number of functions. And we need to read from the memory, in this case, as an empty database plus address of functions of the derivative address, so arrays of all exported functions. The second one basically is the same thing. We need to create an array to order table and reads the memory to orders that associate the names with the correct position in the array of the functions. And the third one basically is the name table. So we need to allocate an array of unsigned long, the number of names in this case. So it's not always equal to the total number of functions. So since not all of them can have an exported name. So, but yeah, after this we just read to RJ where the functions name are stored. And the full class we need basically define target name and preparing to search for the LDR get procedure address. So we need to define the target string to find basically if the name of the function that we want to find, in this case the LDR procedure address. So any initialize and a buffer variable with the same content basically. So this variable will be used to read and compare the name present in the table. And after this, we just need to determine the number of iterations. So define the number of iterations of a loop as a smaller between and the number of functions and number of name. So it's really simple, but this is important because there may be more functions than the names in the exported table. So some functions may not have an exported name. So the loop only goes through to entries with names. So yeah. And basically after this, we need to iterate to find the desired name and reading the name, use the read memory to read from the memory the name of the function. That is the address until the base plus the name table in the index position, and it copies the character into the buffer. And after this, you just need to make a comparison and compare the content read stored in the buffer with the target string to find. And if the match, it means that earlier get procedure address functions have been found. So, and if it's success, we just return to the address. Yeah, so right here, we calculate the absolute address of the function by adding into the base to the value present in the address table, array table, indexing by the correspondent ordinal, so our table and just correct index. So basically, this is the elder procedure address. I'm going back into to the import function. I'm right here to either get procedure address. Yeah, so basically this is the first part, and this is the second one. Right here is the third one. Just to be more easy to read. But yeah, now going back to the import, basically we need to prepare a Unicode string structure. So the idea is to build an Unicode string 64 structure that represents the name of the function to be imported. So basically, we need to initialization about the struct is initialized with 0, and the size definition basically is a length received by receive the size of the procedure name string. So the maximum length um, is set to length plus 1, probably to accommodate the new characters. And after this, we need to setting and a pointer to the name. In this case, we need to obtain the pointer to the string data using the procedure name.data. And basically, and copy 4 bytes of this pointer to the buffer field of the structure. Yeah. And after this, we just need to call the resolution function. It's a call function 64. Basically, we declare a ret variable to store the result. And call the function which is responsible for invoking a function pointer to by LDR procedure address base. Basically, is the LDR get procedure addressing to a 64-bit environment. So we just pass to H model as a parameter, and a Unicode function name. It basically is a pointer to structure contain the name of the desired function that we need to find, and a zero parameter basically is just an additional parameter that user indicate the search should be done by the name, not by the ordinal. And the ret address where the return value, the address of the imported function will be stored. And the last part, right here, it's just error handling. We check if the returns a value other than 0, indicating a failure, of course. And otherwise it returns a value containing the return with the address of the imported function. So I will talk about the call function 64. It's a more complex part about this elongate implementation, but I will try to explain as more technical details to make it more easy. So basically, this function is an implementation of a Havas gate finally mechanism with allow a 32-bit process to call a 64-bit function. Um, so in short, we need to prepare the arguments, load a piece of code, for example, enter shell code to perform the transition to 64-bit mode, and call the target function into 64 bits with the correct arguments and return to 32-bit mode, delivering the return value of the called function. So the first part basically need to prepare the arguments. So we convert a varied arguments to a 64-bit array. So let me present. This is the first part. Um, we have a shellcode definition right here. And right here we have oops the allocation of executable shellcode. And therefore we need to define calling a function via shellcode. But yeah, so basically going to the shellcode. Um, the first part is to prepare to 32-bit environment. So we need to establish the default stack frame, saving the current value of the EBP and making the EBP point to the top of the stack. So this is typically it is typical in the function compiled for x86 architecture. So they align the stack pointer and ASP to 60 byte and boundary. So essentially, for the correct function of the function call in 64-bit environments, where the stack alignment is completely mandatory. So this is the first part. And the second one is just the transition from 64-bit mode. So basically, this first opcodes, we push the value of 0x32 onto the stack. In a Windows on Windows environments, the segment selector represents a 64-bit code. So this value will be used to set the CS, the code segment during the transition. So the second part is executed call that pushes the return address, which we will use in the transition on the stack. So the zero offset calls the return address to be exactly to the next byte after the call. So it's really mandatory. And the third part, that one, we need to adjust the value of the value of the return address, which was just pushed by 5 value. So this adjustment corrects the offset so that when the fire return is made, so the process start executing at the correct 64-bit address state. And a list is performed for return. Basically, it pops to both the return address and the segment selector. So with this 0x33 segment selector previously push, the process switches to 64-bit context. So right here is really simple. Basically, is the register configuration for 64-bit calling. So we transferred the first 4 arguments to the required register on the Windows 6 X64 calling standard. So I attached some Microsoft documentation calling a little bit more details in this case. But basically, we have a 0x67 prefix, is the address size override. Force use 32-bit addressing even in 64-bit mode, while the ARIX prefix 0x48 or 0x4c indicates 64-bit operands. For example, right here or right here, right here. So and after this, we load into Rx the value indicating to the count of extra arguments or another relation parameter. For example, number of arguments to be pushed on the stack. So right here we have the stack alignment just for extra arguments. So we will test the lower part. We test AL to 1 checks the least significant bit of AL port of a AX. So if the result is 0, so the bit not set, basically it's not made a jump. Otherwise, if it's 1, the jump occurs to no adjust, so this point. So if it did not jump, so basically subtract the H from RSP to adjust to stack alignment, so ensure that this is the correct alignment for the 64-bit functional call. So 5 part about the shellcode is preparing pushing some extra arguments if exist. So basically we need to push the RDI, so we save the RDI which will be used to iterate over to extra arguments on the stack. Let me make something more easy to read. Yeah, it's okay, no problem. So like here's the loop just to make more easy to understand. And the second part is we reload address where the extra arguments are located into RDI. So we some test RDX and check for extra arguments if RDX is 0. So there is nothing to push. And if so, we jump to LSE, just part of the code. And the second one, the third one is calculate the address of the last extra argument. So we considering that each argument is 80 bytes size of a 64-bit pointer. And finally, the loop. So while the extra, while there are extra arguments, so RX is different than 0, we need to push the value pointer by RDI onto the stack and decrement RDI the points to provide to previous arguments and decrement the area RX extra arguments counter. So this is we repeat the loop until extra arguments have been pushed, all have been pushed. And finally, the 64-bit function call. So basically, we reload to our AGI to address where the functional return value should be stored. So it's a buffer from the return. And the reserve space on the stack, 32 bytes for the shadow space requirement by some Windows x64 calling convention. And the third is we need to basically invoke the target function. So the address of the function that we call will store in ABP plus H, basically on the spot at the entry of the wrapper function. So the instruction use some 0x67 prefix to issue the correct memory access mode. It's just a really important detail. Basically, right here we need to store the return value. So yeah, it's probably returning to AX through this 64 bits. So the value is a compilable or truncate. So at the address point by RDI, so which was passed by the caller. And finally, that last three operands. We need to adjust the stack pointer to RSP to clear some extra arguments and restore the shadow space of the call. So the calculation invokes the number of extra arguments stored into ABP plus 4H and multiply by a H value and is necessary to align to stack and to fix the space of 50 bytes. So the last is just the pop RDI and restore the original value of RDI that was saved before pushed loop. And finally, we just return to 32-bit mode. So we need to initialize a sequence to exit for 64-bit mode. So this call push a return address on the stack and modify the return address that was pushed to set to the segment selector as 0x23, so which is the 32-bit selector into Windows on Windows 64. And basically, we need to adjust the return address to the correct offset, so preparing for the red jump, to fire jump, and finally execute fire jump returns that pops the address, the return address and segment selector, causing the processor to return to 32-bit mode. And finally, most importantly, we need to restore 32-bit state and finalizing, basically. So we need to restore the data segment at DS in AX and the set to stack segment SS to this value. So ensure that segments registered correctly for 32-bit mode, and restore the original stack frame, popping the ABP and return from the wrapper function. So basically, is this the shellcode to prepare the stack, align stack, and making all operations that we need to calling a 64-bit mode into a into a 32-bit space, calling as Heaven's Gate. Um, this shellcode has some problems that we talk in the next video, but basically some functions on Windows have a lot of arguments and a lot of size but structures. Sometimes need a different alignments on the stack that is not so easy to make a dynamic calculation. So in this case, we can just create a personalized function or a single function to do this. In this case, I will be done with anti-create threadx that I will be explained to next video. But basically, this is the explanation from the rest of the functions. So all of these functions on the HPP file was done. So there is, see you on the next one.
So guys, this part I will show how to execute the memory allocation flow and write the shellcode to the remote proxy memory. But first I will show another implementation of the function call in a 64 bits that, as I say in the first video, I will use it to execute these functions and to allocate virtual memory and to write virtual memory. So remember that I will show the two ways to execute this allocation, writing and execution process. But when I use the entry create threadx function, I will show how to implement it from scratch using inline assemble. In this case, I've used a shellcode that executes a message box. So, and a function exported by a kernel 32.dll. So I leave the attached reference of the creator of this shellcode on the comments from this class or in the last class. So I don't know. But yeah, so first we need to create a virtual allocation. So I create a function to help us to do this virtual allocation first. So actually I will make an extra function using underscore bc expect with a DLL export. If this could be compiled as a DLL, so this should be used at the word is a return value. So DLCL virtual allocation 64. And of course, I need to receive some parameters, and the first is a handle for the remote process. WOW64 from the mode address, the size T, the size for the shellcode, and the allocation type. And the protection type. Yes, protect type. Okay. Yeah, basically this is the skeleton from the function. So let me get the shellcode that I saved for. this is my paste right here. So this is the message box. I don't remember exactly what is right in the shell in the message box. I think it's a meow message box, but anyway, let me see. Oh yeah, the reference is right here. And message box by Kukulin. So this is the reference, original reference, and this is the GitHub. Yeah. So yep. Yeah. First, we create a sign in. So supply my message box range. There's just a size off of the shellcode. Now I will return it from the memory allocation is a virtual allocation for. And maybe pass the handle for the remote process a new value right here as IP address and the size for my message box length and the main commit and the main reserve and the protect type is to execute read write function. Yeah. So if the return address like stack success command, so print f like a virtual allocation fail, can you just return this case actually is different, right? So now I need to implement the logic about this virtual allocation function. Yeah, so basically we have some steps to do right here. I explain some things. The first is the external C, so we need to specify that the function will be used as a C linkage, so avoiding name mingling and making export more easier. And the spec as a DLL export, so this is indicated function will be exported for use in other models. For example, if this function is running on a DLL, so you could compile code as a DLL. The return is just the return address, the return type, I'm sorry. And the CPECL is basically the calling convention most common to C or C++ functions. So the first, I need to import in the native functions. There's a NTDLL and import NT allocation virtual memory. So I need to just auto NTDLL and oops, model handle NTDLL. Remember that I already made this export, so we just reuse the address allocated to memory because it's static memory. Where is allocate virtual memory. Use import function, passing the model that I need to export and the function name that I will search the ordinals and the names. Virtual. So this is basically the first part. Ooh, come on. Yep. And the second one, I need to prepare some arguments, some parameters for the call. So I need to
temp address variable and the temp size that we create to store respectively the address of this size of memory to be allocated. So they will be passed by reference to the native function, which can modify the value of temp address or indicate the address actually is already allocated. Um, so basically, you can see so WOW64 temp address, the LP address. What? Now it's just the size. Right here, I need to call the function. So basically, the WOW64 empty allocate control memory result. So yeah, the third part basically is need to call the empty allocate return memory function using another function that I mentioned before, X64 code. So basically this function that allows to call to made into 64-bit mode, even the current mode is the 2 bits. But there we show another implementation, another actor. So let me see. I have this function into another file, I guess. I think, yeah, it's that one. So here's the function. Basically, essentially, this function is the same as the call function 64 implemented previously, but with some slightly different technical details. So basically, this function implements a mechanism to call up 64-bit, obviously, from another context, 32 bits, and receives a parameter, the address of the function that we call. So that one is a func, and the number of arguments as RGC, and then saves and a variety values. So basically, you have a pragma and declarations, called an accept function, and delay export, etc. And then right here, we have the processing some arguments using a VA list. So basically, the core story capturing the variables arguments which VA stored right here. And basically, we need to distribution of the first four arguments as RCX, RDX, RH, and R9, respectively on the first, second, third, the fourth argument. So at each assignment, if there is an argument available, for example, where the C is greater than 0, the counter is decremented and next value is obtainable with a VA arg. So, and basically we need to return any initialization. So RAX is a return, the RAX is a variable basically to declare it to initialize to 0, because it will store the return value of the called function as a 64-bit convention using two RAX for the results. So basically we have some additional arguments, and we need to store the remaining amount. So we need to prepare of a leftover arguments. So if there are more arguments than the initial first four arguments, basically the address of the first access argument is stored on the rest args. So these arguments will be passed through the stack, obviously, and we store the remaining amount. So the C variable receives the keyword to remain a value of the argument counter. Yeah, basically, and we have a backup variable. So we have the backasp and backfs. So I declare to save the original state of the stack and asp and fs segments, which we restore after the call. So yep, and basically the inline assemble right here
is as exactly the same thing comparing to the older shell code. Some things are different. For example, the fs segment adjustment. So we save the current value of fs to back fs, and they set fs to the value as 0x2b. So this is necessary to correct the handle to fs register, often related to TLS or other internal structures. And the as backup, basically the stack pointer is saved to back as so that it can be restored later after all the calling process. And the stack alignment, basically the stack is aligned into 16 bytes using 0x10 using an AND operation. So alignment is a critical for correct execution of SSA instructions and for meeting our system call more requirements depending on the function. But in generally, all of the function as a 64-bit environment needs this alignment to 16 bytes. And basically you have the macro for 0x64 start that I taught in the first video. So this command probably define an SWR, I guess, but it's used to prepare a transition to an environment where the following code will be interpreted as x64 instructions. So the rest is exactly the same as previously implementation. So yeah. So let's continue to implementation to virtual allocation code. So basically I need to 64 call and pass the virtual allocate virtual memory, and we pass the quantity amount for the arguments. There's only 6 arguments. I'll pass the dual values. Oops. I just copy and paste because my keyboard is too small. I'm not so prepared. So the temp address that I should use, I will be here pass 0 oops. Keyboard temp address 0, but of course to pass that one and as an evidence I use the temp size. Now here is the allocation type, and the last one is just the protection type. So yeah, basically that is the function call, and of course if the success is different from 0 that I did expect. I just print off status for locate virtual memory. I will print the status already as passing this variable. The return address stored in the reacts or return a false. So once time you need to allocate virtual memory, you need to could we print to memory allocated at, for example, and print the value as 16 bytes, for example 0 each and 64 x and raise it temp address This is the workflow for the virtual memory allocation. And right here, now I need to write the shellcode on the allocated memory into the remote process. And I define the size t size at 0, for example, and I call a write process memory 64 right here, and this is my help help function that I need to use to guys. I need to make a cut in the video, so I need to talk with my mom. So yeah, basically now we need to create a write process memory function. So this is my helper function that I be create to execute this part. And basically we use the same structure, but only the return is of void, and of course is a write process memory. And right here we need to handle to H process as WOW64 as LP buffer size t and size and a pointer to number of bytes writing. So this makes more sense. So the first part, you need to import the ng write virtual memory. This is my function. And the second one, basically need to prepare the writing parameter. So this parameter, number of byte writing, if this pointer is valid, so basically the value point to is assignment to bytes writing. So otherwise bytes writing is initialized to 0. So to do this, basically it's to make a simple comparison. So as a zero for number of bytes writing, just bytes writing as equal. So if true longs is initialized to 0. And the third part, you need to create a call. So x64 call, passing the function that we call amount of the arguments. So WOW64 need to convert the type to my process WOW64 LP buffer WOW64 so I use my shellcode. Oh my gosh, is my size of my shellcode. This could be 0. Just my bytes writing or 0. And right here is my into write virtual memory result. And of course, if the result is different than 0, status and return the false value. And right here, I can just print off into write success return value. Yeah. So if you want to see these functions defined, you can just search on the Google for NTPI and the commentated functions. So here you can see what it means. So proxy handle basically. I'm sorry, sorry for the cut, guys. I had to resolve something else on the ride here in my home. But yeah, basically this is the implementation today to write process memory and NT-allocated virtual memory. In the next class, I will show how to create create thread proxies inline assemble. So yep, that is. Thanks. Hello guys, welcome to the last video of Heaven's Gate technique. So in this lesson I will show how to create int create thread X function using an inline assemble. Reusing the same structure that we have right here. In this video I used Windows 11, so I didn't ended up changing the computer due to some problems. But to be more specifically, the version that I'm being used is let me see. Search for the compilation version. It's that one. So yeah, let's start. So maybe copy and paste this function right here to reuse the same structure, or you just remove that one. So yeah, summary, you have a general summary. So first we need to save the current execution state. So saving the FS segment state. So basically FS is a segment register, so often needs user in Windows to access some specifically system instructions. So I will use, for example, the same structure to the back FS variable and FS, and move this value to a AX register, and move the AX, the low part about AX, to this segment. So basically, the back FS stores the original value of segment, here's FS, and then FS is 0 is set to 0x to B, which is a typical selector for a user mode, data segment, or ring tree. So, yep. The second part basically needs to save the current stack. So it's really simple. So you need just the backasp and passing the asp to the backasp that will be used later to restore the stack pointer. And can we execute this 064 start? So yeah, basically I will go into the last steps. I don't know why, but it's basically to returning to the original stack. Mode. So right here we will be back to the 32-bit context, and we need to restore segments and stack. So basically you move to DS segment to AX, and you see AX to SS, and move the back ASP right here. So this basically this support DS and SS basically our secondary register for data and the stack respectively, and ASP is restored to its original segment value into back ASP. So basically I now need to move to the X of back FS, and move fs to right here. So basically we will retire the original value of fs, so in doing the modification mode at the beginning. So yeah, I think this is the main structure that we have right here. So after switching to 64-bit executing context, we need to prepare the register and align the stack. So we need to first moving some values between to the registers, but first we need to create the function and change some things right here. For example, call mt create threadx. Yeah, so we need to put this function right here. 064 nt create thread x result. That's the function, and we need to import nt create thread x, passing as argument. And basically this function will receive an 11 arguments. So first is the thread handle, so we need to create some handle for the remote thread. So I will print some values right here. Thread value. So as a handle, you can print right using the p converter and a pass thread. We pass the h process value also. Maybe pass pointer. We pass also the shellcode address x. And also converting the value to p. Right here, executing the shellcode. I get shell to pause execution. Yeah, I think something like that. So now I need to pass the arguments to the function. So I will pass as a int64 value. This is the first is a h thread. Uh, 64. So basically, the second argument is the desired access, and to create threadx. So the desired access is basically a mask to specify the permissions like thread out access or something like that. So in this case, I will just pass generic execution as access. So int64, then it will pass as a third argument. So basically the third argument is object attributes, and the fourth is a process handle. So basically right here and new, and now it's the thread process handle. So 64. So it's a 1, 2, 3, 4 and the 5 argument is the start routine, so it's a pointer to the function that's being executed. In this case is this address. And the rest could be a 0 values, exactly like this. So 1, 2, 3, 4, 5, and the 6th argument basically is right here is the arguments will be passed to start routine, and the last 1, 2, 3, 4, 5 arguments is the flags and 0 bytes, stack size, and some attribute lists, but this could be 0 at all those values. So I just pass 1, 2, this is our access, 3, 4. So this is a start routine, an argument, create flag 0 bytes, 0 bits, stack size, maximum stack size, and attribute list. Yeah. So yeah, this is the basically the function that you need to call. So looking right here, we can, for example, print these values. So rest of ours, can we just print make a for loop to iterate of the rest of ours. So t equals 0, and if more urge per gc. So just to iterate. So the current arg is the args, and that's the args and the int value. So to get the next argument, and just print argument just arg 0, and print current arg. And yeah, also let me see, I will also print some values into registers. So R9, for example, to see what it happens. So I will print R9 argument to RH, RDX, RCX, and RX. So here's RH, he is RDX, RCX, RAX. So RX actually should be 0. So yeah. Putting right here. So going back to the logic into inline assemble, basically you need to do your process moving values between registers. So basically I use the REX, the real prefix, to use 6-for-each operations, getting the lower part of this register segment. So this is the correspondent register. Remove the AX and pass to ADX. So two functions. So need to push RH value and make a pop operation as a RH register. And the same should be using the R9. Okay, so remember the RX AW is a prefix using to this architecture assembled to indicate that operations should be executed into 64-bit mode. RDX DW is a suggested for RDX structure that contains a 64-bit value, and only the lower part, lower 32-bit port. So it's a double word that is being moved to RDX. You need to make some two push operations that indicate RH and R9 are being manipulated correctly. And the fourth part is to make a stack alignment. So basically it's pretty simple. Rex, W, and an end operation. So basically right here you need to, could be just copy and paste, but there's no problem. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 alignments. So you need to ensure that ASP is aligned to 16-byte boundary. So there's a requirements for some functions called in 64-bit mode. So now you need to make indicating some stack shadow space for that we pass the rest of the parameters to an ISIP64 60 bits bytes, for example. It should be, I think it's okay. So basically I think this is an 104 bytes. So basically ASP is decrement to allocate space to this stack, ensuring there's enough room for storing some temporary values. And basically right here you need to pass the rest of words. So I get some the AVP flash 62 position. Let's do to as plus rest to AX. So this is the 5 arguments, and now I use 0 for AX. Or read 0 to AX and basically make some move operations. So ASP plus 0x20h, add AX, ASP plus 30, oops, AX, ASP plus 30h, AX, ASP, only 0 the rest of arguments. H, AX. So basically you need to retrieve a value from EBP plus 50, 30, 50H, 15, basically this value and EPP on the stack is to make the process place that the value offsets. So we need to retrieve the value. This value actually could be moved because I place some print operations and a for loop. So if you don't plus this print, for example, this for, so the pointers to the args is only being pointed to the same way. So this value in these alignments could be stored into a different way. And of course the print operations make some pushes and alignments that it's possible to make some different alignments on the stack. Especially into a dynamically coded 3264 bits. So yeah, pay attention on this case. So basically now it's just call the function, and I will retrieve to area x.d w0 and ax, the value stored in the error ax. But this is a return value of an t function. Just need to add that as the value of shadow space, and basically yeah, I think it's right. I think this is ended, but here is the call function. Right here is retrieving the function return address. And right here need to restore the stack state. So now in the port, and here is the last. So I think it is. So maybe can be print some the results. So yeah, we need maybe compile the code. Let's see syntax error into code. 1, 2, 3, 4, 7, 9, 10. Variable is, let me see, thread handle variable is not being used. Yeah, it's just because we need to pass as reference pointer. Yeah, I think it's okay. So I open a notepad. And try to execute. So WOW.exe, and execute the shellcode is a get char, and yep, basically the shellcode is executed. So it's just a message box. So yeah, pretty cool. So this is the Haven Gauge implementation. So in this place You could compile as a DLL, changing the shellcode for something that open a remote connection to this machine or something like that, making some multi-stage malware like the Trojan at this case, and execute a thread in another process that is the real malware, or I don't know, make some operations that is not being visible for some secret solutions because the secret context into process was changed. But yeah, code made a lot of variables and different things. So during the course I will show some other examples or other techniques more and combine it some techniques, but yeah, generally it's this the final result. So sorry for the English mistakes, but I think it's that way that I can talk with more people and explain and my knowledge about this case. So yeah, thanks very much and see you until the next time. Hello guys, I come to one more video. In this video I will talk about position dependent code and PIC and how to convert a PIC file, a part of executable file, to shellcode PIC with a PA2 shellcode project. But first I will talk for start with the introduction to PIC. So basically, the position dependent code is a type of machine code that can be executed at any memory address without any relying on the fixed address. So it's a crucial for creating a dynamic libraries and shellcodes, mostly using some security attacks, but which need to be loaded at a different memory address on each execution. So for example, when you're creating a shellcode for exploit like a buffer overflow, so the code must be capable of running regardless of the memory address where it is injected. So what does this mean? That instead of using your fixed absolute address, the shell could use some relative address which can be calculated dynamically at the run time. And yeah, so basically the PIC use some address relocation techniques to ensure that the code can be executed independently of the memory location where it was loaded. So the relocation use the concept of relative address based on a PC. It's a program counter or a base registers, so rather than absolute address. So basically, when the code is compiled as a PIC, it does not contain any fixed address. So instead, you use a relative jump or call instructions that calculate the address during the execution. This is especially useful for shellcodes and shared libraries in case of our DLLs, where the code position in memory can vary across a different execution or instance. So basically in this case, I will use a portable executable and convert a portable executable to PIC. So it's a widely format for executable files in Windows, as you already know what is a PA file, a portable executable. So in this case, I will use this project PA to shellcode. So basically, we need to automate the process to convert the shellcode PIC involve extracting the executable code from the PA file executable session and modify the address to be more relative and transform the code into suitable format for use as a shellcode, and which can be injected into process. So as you know, the PA file contains several important sections and metadata, like a PA header, like the signature, architecture, type, section layout, etc. Sections that executable code typically resides in some sections, .text, .data, etc. Air data. So an import table that contains information about an external functions to be used. So basically what this project we do, it's the process to converting a PA to shellcode. It's basically need to analyze some PL file, and analyzing the PL file, the goal is identifying the extracted .txt section where the executable code, inspection into PL header and the sections of this file. The PL header basically provides some information about the file architecture, like is it 32 or 64 bits, and entry points, and the section layout. And the .txt executable code is extracted from this section. So right here you can see the scope of the project. It's a relocation, imports, and TLS callbacks. But this project doesn't support like graphical interface, or if you have delay load import section, and exceptions that the author say if the executable you convert will be run as a shellcode and throw in some exception, basically the application will be crash. Yeah, during the process you need to transform the code into the shellcode with address relocation, and resolve the dependencies and generating the shellcode at the final. So right here I have this code in C++, it's just a message box. And now if you transform this PL file as a shellcode, so basically I already compiled the code, and architecture is x64. And right here, yeah, of course, you can download the project on the GitHub, going to download the latest version and the release, and download this executable file. So you open my cmd, if you run the code, you see convert speed to shellcode for 32 and 64 BTP portable executable files. So you need to pass your input and your output. So my input file is that one. So we just get to shellcode, and I will patch into my temp as shellcode.bin. So okay. So how the shellcode basically works, so for example, if the shellcode need to call a function for kernel32.dll, in this case message box. So if I have open my CLF Explorer and inspect this program, well, basically you see all the import directory and the kernel32. You see some functions right here. User32 with message box, as I said before. So if the shellcode needs to call a function for some DLLs like kernel32, user32 as message box, the address of the function will be resolved dynamically based on the base address of the loaded library. So, and the code revoke correctly regardless of where it resides in the memory. So we already have it my bin file, so you can inspect the file into an hexadecimal viewer. So yep. So the reason that I went to use a POC in malware development, basically, you have some goals like strategic practice. So especially in the Go is to increase your effectiveness of flexibility of malware code. So like memory address independence. So the main advantage of the PIC is not rely on the fixed memory address. So you have some memory protection mechanisms. So most of modern operation systems use techniques like SLR, so address space delay out randomization, which randomize the memory address where the process and the library are loaded. So PIC allows the malware to execute independently of the memory position, so bypass this layer of defense. And of course, flexibility, so the malware can be inject in any part of compromised process memory. So it's more, don't need to rewrite or adapt the code. Other things like avoid some detection by signatures. So using PIC, oops. Yep. So basically using PIC, the code is compiled to be independent of any memory address, so making it more harder for the security system to identify the malicious code into based on the fixed patterns. This case we use to inject into proxies. So in the next video you talk and you show how to create a proxies hauling, and the proxies to hollow is my portable executable file as a shellcode, so I will import as a header file into my code, but you could be create as in order storing the on other sections, create the other section on your PF file and store the shellcode right here, or as a resource, etc. So, but in this case, I will just make a header file. So let me open. So, okay. Yeah, no problem. So, I will make a variable called an input file. It's the directory for my shellcode being, for example. My output file just on the same directory as shellcode.h. And first we need to read the PF file as a byte. So to open your input file as ready byte, and define this reading as a variable f, and your payload is f.read. And at least you need to generate the file with header file. So I already parse the pattern of header files in C++ or C, etc. So basically on left right there's a pragma nows and split the lines and signage and signature. Yep, payload like, and let's see. Now we make a join as a 4 bytes in payload, and my join need to be f string if a 0x byte with this conversion. I need to close brackets right now. Split the line and make this, and can you split the line again? I guess. Yeah, it's okay. Yeah, it's done, and need to array bytes generated on and my output file, and that's enough string. So 2. And execute the file main.py, and programming code needs some escape. Oh, okay. Right must be str, not a generator. Let me see what happens right here. Join f string 0x byte. Oh yeah. Okay. Oop, never close. Yeah. Sorry for the mistake. Okay, so the byte generate on shellcode in this directory. Just open Explorer like right here. It's more fast. What a delay. So this is my header file. You can open with a notepad, for example. Yeah, and send shellcode. So this is my shellcode. So can I bang right here? So slow, my virtual machine. Sorry. But what I want to do with this file, be patient. Let's create another variable like a payload size, just a lane, a single lane. Okay, of my payload. So yeah, basically this is how to generate a shell code as you see from a portable executable file. So guys, welcome to one more video. So in this video we're talking about process howling. So basically this technique exploits the creation and manipulation of proxies into operation system. The main idea is removing the legitimate code from a newly created process into a suspended state and replacing with your malicious code. So basically I don't place some techniques, more advanced techniques like API hashing, encryption, and debugging. So because my main idea is just to show the technique working. So, but in other videos I will put it all in one or something like that, like a final malware. So yeah, let's see. So let's start coding with some includes. As I say into the last class, I have my shellcode right here. So basically, it's a PA portable executable converting to shellcode as PAC. So I just include my shellcode, and I need to predefine two structures. So basically, the first one is my proc information. So the structs you trying to avoid, like process tab address and process image base address. This is for the remote process, the legitimate process. And another one, it's a type of image relocation entry. So what is this relocation entry? If you go into the PA format documentation, you're going to reloc sec Christ. Yeah, right here. So basically we have the base relocation block. So the base relocation table contains the charges of all base relocation in the image. So we need just values. So right here we have two values that we need to use. So yeah, we have a type, and then first the offset, and the second one is the type, 4 bits, I guess, that one. So, and a pointer to the structure. So, create my main function, and to start I create a okay char pointer to remote target process. In this case, my legitimate process, I will use Firefox. So this is the file location from Firefox. Mozilla Fire. I don't know. I think it's this. Let me confirm. Yeah, this is the right. So yeah, I will start with creating some validations about a PA file. So this is my image loss header, using my payload. So payload is right here, waiting to loading, or not responding. Oh my gosh. Okay. So this is my payload. Now I need to going back to my main file. It's a little bigger file, so okay. nt headers, image nt header. Basically, we need to DOS header to calculate the nt header. So, and convert as an image pointer tr to image DOS header plus image DOS header blah. Okay, and basically if my image nt header, my signature is different from image nt signature, I just return -1 and close the program. So right here, I'm basically making creating a validation if my payload has a valid PA file. So create a printf. Oh my gosh, payload is a PA file. Okay, let me place this brackets to prevent for indentations mistakes. Now I will start top info site to store some information. So I will talk a little bit more about these structures. So and now I need to 0 memory, and I will explain why. Passing the style and the size of the structure. I need to manipulate this attribute cp, the size of the structure, and the same to pb pi. So there is nothing wrong here, right here, but what? Let's say size of, of course. So yeah. So basically, why I need to clear the memory? Before using struct, we initialize them to 0 to prevent some garbage values, but just remember, ensure the outfield startup are set to 0 to both, but process information and startup info. And right here is required because CB store the structure size it's necessary for some API calls. So now need to create a process mode. Create process A, passing the target process and filling some arguments. First tree is not necessary, but here can set it true, and the flags is create as a expanded state. New pointer, the start app infrastructure and the process information. Let's see, reserve incredible compatible with perm. Okay, let's just need to start info way. Yeah, so basically if not remote process, and just make a fail to create target process. Okay. Now I need to start the proc info to get some process information. Can we start the structure to 0 and the proc information? We make some function to get the image base address. So image base address, and you receive a process information PI. So the main idea is this function needs to retrieve the image base of the target process using the thread context and the process environment block. So the first step, oh my gosh, okay. Yeah, so the first step is initializing the buffer. New pointer. And start a context structure. So this context flag as a context foo. So what this means, in practice, the context structure is all the CPU register and other thread specify information. So it be used to store the state of the thread, some pointer, string pointer structure like pab, for example. And the context foo basically tells to the another function that we call and get thread context function to retrieve all the register. So the general purpose register and special register, including some instruction pointers and stack pointers, etc. And now PI pass to H thread and the context. And now I need to read base address, read process memory. It's really simple. So here each process void now I need to pass the image base address as the buffer, image base address, and the size of byte, and new pointer. So basically, if there is nothing base address, it fail. Let's exit the code. Else we return the structure of LP void as a context of RDX and the image base address. So yeah, what we do in this part, what does this mean? Basically reading the BAB address, so the context RDX holds the address of the BAB, so the currency proxy environment block of the target process, and the RDX plus 10 in the hexadecimal. Basically the structure starts at RDX register, but the base address of the loader executable can be found at this offset, so from the PAB structure. So yeah, so basically the read proxy function reads the image base from the target proxy's memory at this address and store into image base address buffer. So yeah. Now we just get it's image base address pass my PI proxy information to store information on this structure. Yeah, now can you print, for example, the target process tab x2p and process information like process tab address, the same to image base address target process image base. So yeah, I think it's right. Yeah, now we need to get the source subsystem. So we already have that one right here. So basically, what is the subsystem? How can I explain? So let me make this first. So I get the word source subsystem is equal image nt header optional header dot subsystem. So in other words, the subsystem basically have some values. So it's a field on the structure image optional header into P file. So describe the subsystem, which is the subsystem that programmers depends. So it's a kind of environment about execution of the binary. For example, in this case, I will print the source image here. If you int value so we compile the code just to show what is this. Okay. So as you can see, the source image is a 2 and x hexadecimal. So basically, the 2 value is the image subsystem Windows GUI. So the executable file is destined to be a file with a graphical interface on Windows. So basically, the program its directory waits to user iteration. So it's not so simple to explain because I don't know exactly, but yeah, something like that. The one value, for example, remember, is the subsystem native. So the program was compiled to be executed directly on the kernel from Windows into native execution. The tree value is something like 2 value. So, but the difference is is a type of program to execute into terminal or prompts. So, and we have other values like a and x decimal, b, h, etc. So, if your source image was 3, you need to compile again your process to hollow and convert to PIC again, because the 3 value doesn't work into process hollow implementation. So yeah, the 2 is the most generic type into this case. So yeah, now basically can we let me see, just do hello to hello, and what is this? In fact, so hello is the process to the function that I create to hello the process. API and API void as the mesh. Right here you need just to pass my API, my payload. I think is this. Yeah. So this is the main part about the process hauling. So it's actually the main function to process hauling. So we have some steps to do. So first, you need to allocate a memory into the target process and compute some relocation if it needed. So yeah, and write into PI headers. So let me see what is the thing for LP process. Yeah, whatever. So yeah, basically let's start. The first, you need to allocate the process. So allocate the memory in the target process. So I will create the buffer again. So alloc address right here. What is this, dude? It's undefined, huh? Huh. Dump. Oops. Oh no. LP Pro. Yeah, okay, that's right. So yeah, let's start. That's in the image. T4. Does p. Okay. And now we need to allocate the memory into the target process is for the PA image. example. Remember, if you want, you can use some NT functions. So, but I don't want to use in this case a lot of defines. Image NT header. Pass optional header with size of image. Comment main preserve and page execute read write. Okay. So yeah, basically now I need to calculate your location delta. So this is the difference of course the delta between the preferred base address and the allocate address. So if the PWX file must be loaded at a different address, the location must be unapplied. So delta image for select address minus image NT header optional header dot image base. And now I need to copy the headers image NT header optional image base like address. And now I just write into process memory, passing the handle of the process. Log address and the image NT header optional header dot size of headers, the new pointer. So basically we are copying the PI headers, DOS, NT, and optional header into a newly allocated memory. So I just print f right here headers right on apps. Okay, so now we already allocated memory into direct process, compute our allocation if needed, and write the PI headers. So no need to copy the PI section into memory and find some relocation table and apply some base relocation if it exists. So let me think. Basically, if any relocation data was found, we need to identify the section. So I have NT function. So yeah, can make image data directory relocate. Just error for now. Image NT headers optional header data directory with image directory entry base relocation, and yeah, I think it's this. So image data relocation. Right here I will just create an image section header with image reloc section. It's a new pointer. And now we need to make a loop through the PA sections. So int a equals 0, is minor done image NT header file header dot number of sections and Encryption ++. So this code iterates through all sections of the executable, so as defined into PI header. So the image NT header is a pointer to image NT header structure, So it contains some peer header into 64-bit format. And of course, the number of sections holds the total number of sections into the executable. So now I need to calculate the address of the current section. So next section header is the image section header. The image section header inch here /t into image and t header plus 4 the size of. I will explain what is this mean. Image file header and image and t header the file header size of the size of the optional header plus header section header. Yeah. So what this means, basically, of course, the image section header is appointed to this structure, which contains information about each section into executable, and the calculation is just following image and t header and skip 4 bytes. It's the PR signature, and skip the PA file header as the size of image file header. And after this, you need to make a send to skip some optional headers, and at least we access the T8 section, so the current section, into image. So and now the image section header points to the corresponding section within the header. So now we need to find some relocation table. So if image data relocate.va written or equal image section header va and image data reloc.va go image section header plus image section header miss at a virtual size. Oh my gosh. What? Please get out. I'm on Windows. Not responding. Help me. Oh no. Just be patient. That way. Yay. Okay. I don't know what happened, but now it works. Okay, so basically I need to image reloc is equal image section insert command. Okay, so yeah, okay, basically in this part of code we find the relocation section and check if this data relocation, the virtual address the base idea of relocations is within this section hangs, and if true, basically the image reloc section stores a pointer to this section. Yeah, and basically, yeah, this is useful for ensuring that relocations proceed correctly when we loading the PA. And yeah, now, oops, we need to write process memory PA h process p void unlock address plus image section header true address to, okay, okay, p void as UAC64 the image section header and pointer to row data, and yeah, basically this is the buffer. Image section, I think it's the image section header. Come on. Okay. Size of row data and the new pointer. So basically, what is this point of code? We are copying the section to the remote process. So this is the destination address into remote process. This is the source address from the PA file. And this is the number of bytes to be copied. Let me see. Okay. And now I can print F like section F section right at P and pass to P the image, the name and the address. In 64 unlock address plus image. Yeah. Okay. We can print the relocation section. As a SHA converted to SHA pointer. Image reloc section at name. Yeah, so now we need to apply this base relocations. Drink some water. Sorry. So now we need to apply this base relocation. So reloc offset is equal 0, and while reloc offset minor of image, it's a data reloc image data reloc size. Okay, so basically the image base relocation. Yeah, so and pass as the word 64 value to image plus image reloc and a pointer to raw data plus reloc offset. Now the reloc offset for plus size of image base relocate. Yeah. So basically the image base relocate is appointed to the current relocation block, and the calculation was pretty simple. So I have the base address of the image into memory plus pointer to relocation table inside the image, and reloc offset is moved through the location data structure. So the offset is increment to move past to this relocation block. And now we need to get the number of entries. We need to make an image base relocation minus size of this image base relocation structure. And right here we just divide by the size of a relocation entry, so give the number of relocation entries on this block. Yeah. Relocation entry. Okay. So right here we are subtracting the remove the header size, leaving only the entries. Now make another for loop if the word value, and if it's minor number of entries, just iterate. So right here you are basically iterating over individual relocation session, such as image relocation entry, your image relocation entry, and pass the word 64 and image plus image reloc section pointer to raw data plus reloc. Code size of image relocation entry. So basically the image relocation entry points to individual relocation entry, and the offset is increment to move to the next entry, like a node. Makes sense? So I need to continue the loop if there's not a valid relocation entry. Type equals 0. Just continue. And now we need to calculate the address to path. So address location click towards full. If I lock address plus image base relocation as a virtual address plus image relocation entry and offset, and then you make a variable to control with patched address. So now again basically the address location is address into allocated proxies where the location needs to be applied, And the calculation is simple. It's just base address of the location memory to remote process, plus the virtual address of the location block, plus the offset within the block that needs to be path. Now we need to read the original address for into address location, so into the remote process. So I need to manipulate into with the delta image with the process memory. I h process p void address location, and oh my gosh, patched address of WOW64 and the new pointer. So, and right here make the patched address go delta image, and now we need to write the patch address. Oh my gosh, there's location address and the size of the words is full. Exactly the same thing. So until we have this, the relocation was done. Now we need to store again the context of the process. So add dot context flags, context foo, and get the thread context fda h thread context. So now we need to update the process environment block, the pub, and update the pub with a new base address. And basically the pub stores some other information about the process, so modifying sure the Windows recognize correctly a new PA location. PH process void. So again, contacts are contacts. It's really slow. Image nt header and optional. Optional header dot image base size of WOW64. Okay, so now you need to modify the execution context right here, setting to new entry point, and update the CPU context to execute a newly injected portable executable. So the entry point, the EP of the PA, is calculated and stored in RCX entry point referring to x64 bits. Basically 64 and alloc address plus image nt header entry point. And now we need to set thread context a thread context and resume thread h thread. Yeah, obviously, can I return true value? Let me see, something's wrong right here. Yep. Yeah, I think that was done. So basically, hello, different and true, equal true. So injection succeed and return a zero value, else we just return a -1 value because the code should be done right here, and can we terminate the process, each process with -1 and close the handle a.h process. So yeah, can we compile and the test? See, so let's run, and yeah, right here, can I open the process hacker? And right here we have a Firefox new entry to this memory address. Or that one. Yeah. You can search. Okay, no problem. We find manually. 69 CFA is the base address. BGB FA2 right here. So right here we have your program. So if you probably search for, go to, I don't know, just offset, want to find for hello world, just a string should be right here. But yeah, basically now the process holding is working, and this is the technique that we learn into this video. So yeah, thank you very much and see on the next video. Bye.
Hello guys, welcome to another class. In this video I'll be talking about the UAC bypass. It's a process elevation technique to get an administrator on a Windows environment. So we will attach two researches. So this is the first one that I will talk later, and this is the another one. So basically this bypass was found using a binary on Windows called cmstp.x. So basically it's a connection manager for profiles in Windows. So this vulnerability was reported to Microsoft, but they closed it a few years ago. So definitely UC is not a priority for the company. So this flow as well and the other series are unpatched and can be used in any environments. So basically, when you run this command, you have a couple options to use. AU is basically to auto elevate, but basically we wanted to create a profile and showed a look like how to create one. So after some time, the research discovered there is a connection manager administrator kit, it's CMAC, that created this profile. So he installed the program into the control panel. So and followed by step 2 instruction to generate a connection profile. At the end, some installers are created with EA Express, as a Microsoft compressor, and inif file. So this is in file has restrictions for remote users to connect to a new connection of this is a VPN based on CMAC. So this information is available in the research, so it's more completely, and I really strongly recommend to read, to get some credits to the creator and the researcher. So basically they can run this file as AU passing in a file, so in a file, and it creates to auto elevation. So but basically if I created I don't know, let me see, is in my videos, going to ctemp, and this is to its old files. Let me create a new one, document with I don't know, bypass.inf. I think we need to pass any argument, but let me see. Yeah, so let me get some notepad and paste the content version. Okay, and yep, so basically when you click on the run, the prompt with administration rights disappears. So as you can see, of course the system cannot find some specific file, but we are fixed that error. So the interesting thing about this executable is that not have an auto elevation. So this binary does not have an auto elevation by default in your manifest file, but even so, this specific function can auto elevate. But yeah, in the article they auto say right how can it be possible. At the point is to realize that function make a VPN connection available to other users could archive an auto elevation. So however, the image executable window when open remain at the same level as the user rights, regular user rights. So basically, yeah, let's start. You create, if you can see, this is C# code, and this article have another one, I think, and a PowerShell code. But I create a C code to make it possible. But first, I will explain what is these fields that you need to use to generate the bypass. So basically, you have the version statement with this signature. So basically, as we all know, it's marked into in files. So it's actually a signature that indicates the file is recognized as a valid installation file by the system. So we use this value is conventional in many files, especially that employ advanced features. And this one is specific in file used at advanced in feature introduced in later versions or Windows. So the default install field. So this directive, that first one, so tells the installer to use a custom destination section. So it defines where certain settings or file might be placed during the installation. And the run preset type commands basically is the command structure that installer they execute the command specifying to this this field. Um, Basically proceed any with any future installation steps. So in this context, it used to trigger the malicious command section. So this is the malicious command section. So is here to make it a bypass. So first we have the command. So in this case, actually this command was not that I want. Let me see. Command so replace command line. Yeah, makes sense. So right here we need to place, for example, System32, Windows, PowerShell, the oh Christ, I don't remember. Let me see. Yeah. U1 oops .0 slash PowerShell.x and make a line. Oh, it's not. It's okay. So yeah, so this is the first command, and after we have the task queue. So after the elevated command is executed, so this command forcefully it terminates the compare STP process. So this cleanup is a crucial to prevent the installation process for continuing normally. So which might otherwise display in any UI elements or error message. So we don't need it. So we just make a task queue. So this line creates a mapping. So what is this? This number serves as an identifier that points to another section. So this our user LDIG section, if this parameter is 7, in this case this mechanism is typically used to define how and where additional configuration that data should be applied during the installation. So this is the configuration that we use during the installation. This is a registry operation. So this entry instructs the installer to write to this path on the Windows register. So right here we have the key, typically used to define some application path, and this is the to value name and the profile path install, and this is the value used. So it's a placeholder that may be substituted or interpreted during the installation with or empty strings for additional parameters. So although this operation might seem in the beginning. And right here we have the strings. So basically the strings is entry defines constant that you use into file. So they simulate a naming of a services figure reinforcing the premises or standard installation profile. So yeah, basically this is the file to create a bypass. And now let's get to the code. So first let me open my Visual Studio. I already creating a file, a project right here. So sorry, my Visual Studio was crashed. But okay, let's start. First I make some imports right here. The Windows cdao.h, cdao.h, char, and the strings. String actually. So okay, first I will make a typed abstract to a callback to find some Windows window proxies. So just to find your PIG and G and WNT, it works as a window search data. And yeah, and now I make my main function right here, and the first step, I will create an inf file. So I define a temp path with a max path defined, and inf file path is also the max path also. You see, as I try to get the temp file, the temporary path actually, passing the max path and the temp path. So if this comparison is equal as 0, basically I will use to my gprintf. So fail to get a temp directory. I need to conversation, I guess. As tprintf and return one value. And now I make to as the printf if inf my inf file path, and passing my cmstp inf file into my temp path. Yeah, makes sense. And now I need to create a content of inf file. So just a sharp pointer to inf content, for example. So this part is it's not so cool to do, but okay, let's do something. Need to make some escapes right here. As signature and advanced said so. Line break, default style, line break, small, easy to do, something like that. Run preset comments. Another line break. Run the preset command. And I don't need this port, it's a PowerShell. Now the task queue command. cmstp, yeah, that's right. Values. Remove all the spaces. And right here, maybe we need to make break, something like that. Yeah, let me see. So one more break software another one right here, and in this unexpected error. And now it's a 1, 2, 3. So 1, 2, 1, 2, 3. Yeah, makes sense, I guess. I think it works. And yeah, right here you need to do the same thing. Here, right here, H, da. R/n. Yeah. Makes sense. So now we need to create a file. So it's pointed to a full open function if file path as right, and if there's no file path, oops, just make t printf like fail to create inf file path p, actually that's fp a pointer, yeah, and return 1. So now after write if inf content size offshore and strlen to inf content to write on the file and close the file. So I think to create a file, so in file created at file path. Okay, so now we need to prepare the complete the path for cmstp.x. So mstp path stp. So now I need to make a get system directory smtp cmstp path for max path equals 0. Just fail to get system directory, return 1. And now ts cscat to cmstp path st passing my mstp.x. Okay, now I need to create the command line cmg line 3 max path and st printf passing cmg line, and right here need to pass the auto elevation command. So basically need to make this line break right as/au passing the as formation, and one more, yeah, makes sense. cmstp path in file path. So oops, okay, and now we need to define the directory, the work directory. So char the work dir max path tcs play work dir stp path tcs cp, yeah. Last yeah, okay, just last dc as do you remember c as yeah, is that one work dir st make another break right here, and if last slash basically the last is equals 0 and the directory was done, it found places 0 cs, yeah. So now we need to go into third step, is a create process creation. So use the start up info as SI and process information as PI, and need of course to 0 memory, and passing the SI and size of the structure and size.cb si.cb low size of si. Okay, so if it's any fail into create the process, and you pass command line a new value, a new actually it's try attributes is it's a false, yeah, it's a bool, so 0 and void is new, and my org directory is my current dir, and as I start web information and my process information, so gprintf is a t, so create process fail and pass your code right here and get last error, return 1. Okay, so if it works, of course the process to printf g process cmstp.x started, and waiting for the window. So now we need to wait until the window for the process was appear. So ng it's wait for window and pass the pi dot the process ig for 10 seconds, and if is equal no, to print off just cmstp window not found. So yeah, but else return is 1. So Anyway, we need to get the first window, so show window g m actually it's a nd, it's not md. And as to restore the window and restore. And now basically I need to implement these two functions, so but there's no problem, so I need to start the foreground window and g and g printf g window activated, so and send enter key. So yeah, now we need to implementation this function, so the wait for window, and basically need to return hng wait for window. We receive a PIG and it's as timeout. So start with the structure window search data as a data. Window search data, yeah, I think it's right. So data pg equal PIG and data and Windows data and ng equal no. And we need to wait it, so make just a counter, so while waited minus the timeout, just make a new Windows and Windows proc param and passing the data. This is another function that I need to create, so it's just a bool because it's a callback and new window proc g and then ng and then param is param and return it true. Actually no windows proc, just not window. So if data dot those is different than new, just return the data though. Anyway, you can just sleep 1 second and waited plus send 100 and return new. Okay, now we need to create a callback, so window Windows search data as data, Windows search data param and the word window ig equals 0 and get window thread process ig d and my pig. Make if window pg is equal data pag, basically we data is equal my window handle. I return a false, and actually the window must be visible, so is window is visible ng. So yeah, I think this function was done. So now we need to send an input, so make an input, cool, start as 0 and simulate the enter preset, so but type equal input keyboard if it's echo dot qy dot k, so the key is a return, and the flags a.dw flags is just a 0. And now we need to create a simulation for liberation about the key. So the type it's a keyboard, and flags key event key up, and send. So we need to use send input passing 2 and inputs and the size of my input. And if you send is different than 2, is basically the t that one fail, send, enter. Yeah, actually this is probably should be work, so let's compile. Christ, let me see. Function maybe unsave, use searchy. Oh yeah, of course. So need to define CRT secure no warnings right here. Try to compile again. Yes, and let's start CMG. So as you can see, I just have this couple privileges, and I will execute now the bypass. Failed to create my inf file. Let's see. So I have the f open in file path. No in file path. Oh, let's see. Yeah, the formattation right here. Press waiting for the windows, so you don't pass the arguments. So choose the support, waiting for started. So I started waiting for the window, so wait for window, passing the process ID, and if it's no, so probably the window is not found. So let me see. Windows search data, PG to PG, NG, no, timeout, and the Windows, passing my no Windows proc function, parameter, passing the data, if different than new, just return slip for, yeah, probably get process ID in a window. Let's see. Yeah, so guys, I'm back. So basically I make a mistake using an fopen file because the type conversion was different. So we are using the this pattern of Windows functions call with W into the end. So of course the type was different, so the in file was not creating at this time. So now it works. So I make some changes into the code. So the first, I created this helper function called as created in file, and right here basically I just copy and paste my info content and create just two variables, hfile, handled_file, and bytes written. So I pass as argument to this function the path for the temporary path that we get before, and right here I just make a create file function, pass in this file path with the right arguments and creating and this and other arguments to the function. So if any errors occur, we just print error right here, and right here I write to the file. So basically writing to the content to the file, and if any errors occur, basically we print the error, but else we just create the file and close the handle. And basically is this the only change. So basically you need to compile and you open the terminal. So as you can see, this is my privilege, so running the code and open my PowerShell as administrator, and who am I? This is my new privileges. So basically this is the technique. So thank you very much and see you in the next time. In this video we talk how to create a Chrome stealer to get cookies and credentials. Actually I only show how to get the cookies, but the logic to get the password or the credentials stored into cache files is quite simple. Maybe in other video I would take some time to show how it works. Actually I will make the code and C# actually into .NET 8 structure, so it's more easy to create something like that stealer. So I will create new project right here. Okay, and the first create a new file like Chrome stealer. And first I create a new class to impersonator, and I will add some dependencies to the code using your NuGet as a package manager. So first I will install a new soft JSON to manipulate some JSON files. SQLite, Microsoft core system data SQLite. Another one is NSEC cryptography. And yeah, initially I think it's okay. Naming namespace as just program, create a class program. yeah, let's start with something like that. In this class, basically, I create some methods as an each point to LSAS handle. So actually, I need to impersonate the LSAS process to get assistant privileges. Inch, yeah, exactly. And another one, another pointer, like duplicated token. Inch ptr .0 again. And I make some imports. First is a ntdol .dol and a private static extern inch rtl adjust privilege passing privilege. There's a privilege number. There's enable view current thread and an output previews value. Extern inch. Right here I make another import as a API 2 and I will set the last error as true. With static extern view like an open process token, into pointer as a process handle. Exactly. Another easy creator 2.dll. Set again the last set was true. View duplicate token. Existing and token handle. Inch personation level and now into picture duplicate token handle. So I just copy and paste to impersonate logged user and reverse right here where kernel 32 and I already create a private static extern boo close handle. Handle object. Right here, static extern boo and reverse this off. Static extern boo and personage log it on user passing pointer to token handle. And yeah, that is the imports. So let's start enabling set the big privilege. So I need to create a function called enable privilege, and if rtl adjust privilege 20 and true and false, LA and IOTB is a previous value. It's different article different than 0. I just throw a new unauthorization exception error, like fail to enable say debug privilege. Really simple. You create a private void get LSAS handle. Alright, I make a for each into for process in process.get process by name LSS, and actually right here. So yeah, okay, so LSS handle equal process dot handle, return, and throw a new exception if the LSS .exe process not found. To get the pointer to this process, so now I create a private int pointer to get system token. Now I'll not access the token as static. Yeah, no problem, I guess. So process token else says handle. I pass the process token, something like that, or 20h. Pointer token handle. What? I need to pass the process handle, and of course I forgot to desire access. I like range, sorry, access. Okay, something like that. Throw an authorized exception, like failed to open access token. Duplicate token, like token handle, passing percentage level as 2, and my out int pointer as a duplicate token handle, and close handle, and throw a new authorization exception and error, fail to duplicate SAS token, and you close handle, the token handle, and return the token handle. Okay, and now we need to create a start public void start function, and right here we need to enable privilege, get LSAS handle, but actually okay, and duplicate that token, it's equal get system token, and if there's not impersonation login user as duplicate token, just throw new unauthorized access exception, fail to impersonate system user. Okay, and right here I create a public void close to revert to some presentations and close the open handles. So it's quite simple. We just revert self function and close close handle as duplicate token, and close the SAS handle. Okay, so this is to impersonate your class, to impersonate the LSS process, Um, mm, yeah. Now can we start at working in the main class and the main function? So I will start with public static void as encrypted key. So I probably make a video talking about this values. What is the AS key or Shishay 20 key, and talking about elevation process to head to Google Chrome and how to get these private keys. So you need to get these keys to decrypt all the values stored into local data and probably in the cookies file to respective profiles into Chrome directory. So I need to sort like a create a string to browser. So I need to press a Chrome, but actually it could be an Edge and a Brave, etc. And I need to get to my local app data. So get the environment dot get folder path environment show folder, not local application data. So basically the environment get folder path function needs used to get the path of the current local app data function as logged users, and the local application data is actually is enumeration. Like as you can see, it's int value represent the local app data folder. So now we need to create an dictionary as a string and pass some values, a string key path, a string db path as browsers call and new and yeah, this is right. So in this dictionary I need to name it some browsers that it creates a map that supported browsing in this respective important file paths. So in this case I will only pass to Chrome browser. So Chrome, yeah, that's right. And make a path dot combine local app data and pass the Chrome directory, Google Chrome user data local state, and another one is a path combine and pass the profile directory to get my cookies file. So data, actually I get to profile 4, but you should be create a function to get these profiles dynamically or get only the default profile. Work and cookies file. And right here, this is my directory. So now we need to impersonator as equal new instance the class and impersonate dot start. And now you create we have a browser dictionary and use it to access the browser with key Chrome into the example. So I have the tuple path as a key path and db path associated with the select browser, storing the select browser available. So the key path and the db path that I use, and of course the path of the local state file is a key path and cookie database. So create a new variable browsers passing my browser, but actually it's a dictionary, and string key path selected browser.key path, and string db path path. So here you need to get the local state content and the file read all text passing the key path. So basically the contents of a local file are read and stored into local state content variable. So the local state is a JSON file that contains some settings and encryption keys used by the Google Chrome or other Chrome based browsers. So yeah, you need to use this function to read and obtain early endpoints to the function. So you need to make a dynamic key variable as local state as a JSON convert to serialize the object local state content. So the content of the local state file is a JSON format are deserialized into a dynamic object called local state. And now we need to get encryption key. We need to just extract from the local state object. So I create like some app bound encrypted key variable, and from 64 string because state and get my OS script key as app bound encrypted key. So to convert this function, basically we convert the string back to the byte array and you store into this variable, byte variable. And of course this value into a JSON file is a base 64 encoded string which represents the encryption key. So now I will just say encoding.ascii and get string and app bound encrypted key. So we need to start with app pv. So if possible, we need to throw some exception called invalid key format. So yeah, basically the encryption key start with this prefix, so in ASCII format. So we need to search for this value, and if it's possible, we just get a bound encryption key as a bound encryption key. As for create for two dot points operator into a new syntax to create a new array from index 4 to the end of the original array. So after this operation, basically that bound operation that bound encrypted key contains only the useful part to encryption key, so without the prefix. So in the next class I will show how to decrypt this values. For now it's okay, so you could just compile and of course call the function right here. It's a Chromium Stealer and using a Chrome Stealer and the namespace encrypted key. Namespace Chrome Stealer class Chrome Stealer Chrome, yeah, makes sense. So to open my command as administrator. And get the exe file. So let me see, enable to find an entry point, RTL adjust privilege. Let's see what is the problem. NT DLL.DLL RTL adjust makes sense. It's wrong. So it's okay if there is no throw exception, so the code should be run as successful. So yeah, in the next class, as I said before, we need to decrypt the value. Yeah, there is. So thank you very much, and see you in the next class. So guys, in this class I will start to the decrypt key that we made into the last question. So let's be quickly. I will create a function called decrypt with GP API. So basically, what is this function? So, but a step-by-step explanation. Basically, we need to prepare the encrypted data. So the function needs to receive the array of bytes. So that one. This is encrypted data and contain with the encrypted data, and the data needs to be encapsulated into a new structure, a data blob structure. So I will talk about the structure later. But yeah, first, let me see. Now we have this couple of functions. Yeah, no problem. So basically we create an priority stack method. Oops. You receive a byte. It's decrypt FTP API, and we will receive a byte array. It's encrypted data. So now we need to create a data blob, and basically it needs to input blob with a new data blob structure. So basically, what is this structure? So the data blob structure is a structure used to encapsulate some encrypted and decrypted data. So let me make some things right here. I need to create a stretch layout, and basically need to pass a layout kind sequentially and a short set, and Unicode short set, and create the private stretch and data blob. And basically we need to interceive the data. It's int pointer to PV data. So basically this is the size of the data into bytes, and right here it's a pointer to the actual data. And yeah, I think it's good for now. So create the output blob. It's basically the same. It's a new data blob structure. Okay, let's go into the PV data. It's I will use a Marshall like log h global with encrypted data dot length and marshal copy to encrypted data and pass some parameters right here and put bob.pb data and encrypt data dot length. So basically this is need to allocate an management memory. So the management memory, we use that function to store the encrypted data, and the encrypted data it's copied to the allocate memory using the marshal copy function. And now basically need to make some decryptions with another structure that I need to create. So but first, data, it's encrypted data dot length. No problem. Yeah, now I think it's okay. So right here I create another structure that we need to use. So static on extern like crypt yeah, I think it's not that it's okay. Protect data. So I will create some parameters right here. Make a reference to data blob. It should be data in, like an input data, and pointer to pb seekers and data description. It should be here to be optional entropy. Another feature to pv some observer data, and pointer to p prompt struct. And now some flags and another reference to data blob as p data output. So yeah, basically the first it's a data box structure that contains the encryption data. The second one, it's a data description, it's a pointer to string describable into data. We not use it right here, but yeah, this case pointed at 0. So the optional entropy is pointed to additional data during the encryption. So always is be 0 in this case, but the reserved is it's wrong. Okay, it's reserved for future use into actually encrypting protection data structure. And be prompt structure is basically it's a pointer that define the prompt behavior, and always we don't use. And the flags is the flags to control the behavior of the function. So means basically 0 is the default, and to data blob, the data out is the structure that we receive the encrypted data pointer. So yeah, basically we pass to crypt and protect data, and pass to input blob, and we right here, as I say, we pass 0 into some 1, 2, 3, 4, and the flag will be 0, and the last one is a reference each output blob. And we can just throw a new exception like fail to decrypt data using TCP API. we create a byte array to decrypted data. It's a new byte array and output blob like cb data, and we return the decrypted data right here, and make sure we copy the data. So blob like pb data to decrypted data 0 to the start index, and my range is blob like cb data. So yeah, basically it is. So I need to now make a free memory. Blob like pb data marshal like free level to put blob like pb data. Yep. Let me see. It's of pass one more argument as necessary. So yeah, basically this is decrypt with the API function, and now can we call the function right here, pass in a byte array like decrypted. Actually, it's need to encrypted key and make a decrypted with the API, and I pass my add bound for Chrome key. So this is the first one. And close the we need the close method to of the impersonator class is called to end to impersonation process. So basically we need to revert some security context if plus success to back to the original state, so to user. And now decrypted key, I was passing the decrypted API key with the encrypted key. And can we make a console right line convert same decrypted key? Nope. Actually, I was just make wrong. Okay, so yeah, now we need to get the decrypted key data. So I will create another function called static byte remove validation data byte data. Basically, this function is responsible for removing some validation data or padding for the decrypted key. So in the context of the codes of this code, it's used by proxies to decrypt key obtained by the API. So basically we need to get the bit converter to int32 and pass the data. And what it means, we need to extract the size of the first 4 bytes. And right here is the extracted data.skip 4, and take a size to array, something like that. The remaining data.skip for the size to array, and then basically the remaining is the output byte to remaining, and just return to extract it without any problem right here. So need to create another static byte to remove validation data, and just pass the byte array data. Actually, it's not, I wrong the name, it's just a pop string. This is the main function. I need to create a pad porter, and now pop the data, and now it's padded right here, and return pop from string, and pass nothing to right here. So this is the remove validation data function, and right here just a byte decrypted key data is a remove validation data, passing the decrypted key. And now, as if it's a string, you make a write line with bit converter, but to string, to decrypted key. And actually, I forgot to error again. Yeah, basically we need to remove the padding, and now finally is the key to decrypt Chrome key, and this is my decrypted key data. So basically it's the one of main most important functions. So right here is my public static byte decrypted Chrome key, the byte array with encrypted key. And now basically we start creating a encrypted key dot length 32. We just return the encrypted key, because if the encrypted key size is at 32 bytes, the function returns the key without decrypting. So this is because the 32 byte keys are generally not encrypted by the Chrome and already into the correct format. So now I have a really important part. I need to get the private keys into elevation servers. So basically, let me see. I will make a cut to get my this string. That one. So okay, for part of my code, basically right here you need to create another function that calls private static byte with string byte array and receive hexadecimal string. So number chars is hex.length and a byte with bytes, equal new bytes, new byte array, the number chars 2, I go equals 0 info number char go plus equal to e plus 2 is equal to convert byte to byte array into hex.substring I into 60, yeah, and return the bytes. Okay, well, this is a generally function to convert a string byte to array. So I will open the elevation service to show something to you. Chrome. Okay. Can we open with my xt? So right here we can found this key to for everyone some Excel value. So right here we have the key into elevation process again. So and the AS key basically it's a different one. It's not integer, I guess. The Excel value. Yeah, of course it's different, but yeah, it's because it's already converted into base 64, but that one it's a hexadecimal value, so this is a base 64. Oh, but if you convert to hex and you search into the elevation process, you will found the encryption key. So yeah, basically can we continue create some variables like flag to encrypt that key, zero index, and create a byte array if IV is a new byte. So I'll explain exactly what is this. One pass the IV and 0 to that value. So let's write actually create a byte ciphertext, a new byte for 32 value, and make another array to copy into my encrypted key 1 plus of cipher text 0 and 32. And of course inside of the function, so create another byte array, pass a tag as a new byte, see, and we are array.copy to encrypted key, and again for 32 passing the tag 0 and 60 value. So first, the flag is the first byte of the encrypted key. So this is the flag with basically indicates the encryption key algorithm that being used. So You have the ASGACM and another one's a HA20 like poly algorithm, so we use the second one. The 4 basically this validates the initialization vector, so the next 12 bytes like encrypted key 1 dot dot and wherever the value are the initialization vector, so needed for the encryption. And the cybertext basically is the next 32 bytes, so are the cybertexts, or of course it's encryption data, and the tag is the last bytes. Basically we are the authentication tag is to verify the integrity of the data basically. So yeah, basically now can we create another byte like decrypt that key, and now create a try and a catch like cryptograph exception E and just throw whatever. So basically we make the if a flag equals 2, it basically uses the decrypted key is equal we use another function that already made, but yeah, into poly 64. This is the function. Always I forgetting that one. Else, just know a true new an argument exception with some unsupported flag, and passing the flag that I be using actually. So okay, can I just catch another generally exception? So and just throw and right here return the decrypted key. Now basically we need to create this function using some libraries that we already import. Right here I create a private static byte with to receive the key that we use. The byte it's announce, another byte it's a cybertext, and then last byte array is a tag. So let's click the out, so we need to AG algorithm dot shape poly 1, yes, that one. Now you need to import the key, so it's a clear Bob. We already have the key, so we just import passing the algorithm that we use, the key passed to the function, and the clear B blob format like row symmetric key. So now we need to combine the server text and the tag. Is required by the nsec library. So combine it cybertext. It's a new byte array. It's a cybertext dot length plus tag dot length, and we create an array. Copy. Passing 0. Cybertext and the array 0 again, and cybertext dot length. Copy again. Tag 0. just decrypt to the plain text. So new with the length of the ciphertext and aug.decrypt, passing the key. Lob, pass the nonce, the default value, clear cessation data, combine the ciphertext and the plain text variable, and just return the plain text to decrypted she policy. Yeah, it's now right here. Okay, right here. So we need to pass the she key, AV, the ciphertext, and the tag to the function. And yeah, so right here I can just paste it console the right line, cryptography, get the message for the error, and also get the track. I think it's track trace. He's basically the same thing, but just error. And yeah, now this is the function to decrypt it. The Chrome key, I guess. So decrypted the Chrome key, and for the list we need to just read the cookies passing to the B path that we already configured right here. But let me see. Yeah, can we continue, I guess? But my computer is not so good at all, so if my video pass to 30 minutes, the rendering and the so long time, so I will stop the class right now, and the next one I will create the last function is just read the cookies file from the DB path. So basically this, and see you in the next one. Hello guys, in that class we will read the cookies and decrypt the cookies from the stored data file. We need to make some fix into our last class. So basically I just added this line to import decrypt32.dll. So we need to import that one to use the encrypted and protected data structure. So now we need to read cookies and decrypt the cookies. So basically we create cookies variable passing a read cookies, and I know I really have to pass the DB path as a variable, as a parameter to this function. So basically, can we put that one right here? Like a static list string host key string name and a byte with the encrypted value. Pass the ready cookies as string and receive the DB path. Oops. So basically can just make a right line into dbpath to see what is the database file that we are looking for, and we create a new variable, to a new list basically, to store the cookies. So basically string, passing the host key and this other string name and a byte array encrypted value. So now we need to connect to the database using the SQLite. So can I or connection new SQLite connection, basically passing the data source as dbpath Odigo ready only. Connection.open. And we now need to create a SQL command to select the cookies. So that's the connection.create command, and command text is equal select host key name and guest as encrypted value as blob from cookies. And now we need to execute that one. Yeah, exactly. So while rather not read. So now we need to read the values and from the columns. So dot get string 0 reader dot get string 1 and a byte as encrypted value equals byte new dot get value 2 use dot add get the host key name and encrypted value. So okay, adding to my oops just one right here, it's a syntax error. So this is read cookies. So now I need to filter the cookies where the encrypted value start with v20. So basically something like this. So go equals a new list string key byte for each or cookie into cookies dot encrypted value dot length and cookie dot encrypted value, the first one index equals v and a cookie dot encrypted value 1 equals 2 a cookie dot encrypted value 2 equals 0. So basically we need to get the cookies dot add cookie and finally return the cookies full. So this is the read cookie function, and now yeah, can we make for each into substitute var cookie in cookies and string to the encrypted value. So we create a new function called something like decrypted decrypt cookie v4, and basically we need to pass the cookie encrypted value, the cookie and host key and the key. So now basically, let me see, we need to create another function, I guess. Encrypted key. Just to be more useful to read the code. So yeah, string encrypt cookie, and you receive the byte as an encrypted value string to main and the byte key. So basically, first you need to extract the IV that has been stored after the 3 bytes prefix into the encrypted value. So basically the method need to extract the 12 bytes starting for the 30 bytes, and need to extract basically the encrypted cookie. So the cookie data is stored between, as we see when we are decrypting the JJ right here, it's stored between the IV and the authentication tag, starting at byte 15, I guess, but yeah, let's see. Just new byte as array. I need to copy the encrypted value into 3 prefix and the cookie IV passing right here. Now the encrypted cookie new byte in encrypted value dot length minus 2031, something like 3 prefix plus 12, that's IV, plus 16 is a tag. So essentially it's this. And now we need to make array copy into encrypted value chain and encrypted cookie 0 and encrypted cookie dot length. Okay, so this is the cookie that has been encrypted. Now we get the cookie tag as a new byte. Now array dot copy and encrypted value dot length minus 16, cookie tag 0 and 16. Okay, encrypted value, cookie, that is right, I guess so. Now we need to use a as GCM inside Omigo ASGCM cd key. New bytes. Plain and ASG that's right, to decrypt method using cookie IV, an encrypted cookie, the cookie tag, and encrypted cookie. Yeah, and now we need to trying to the code. Turn a bit converter to string. It's a final. I need to actually make a new final cookie because we have we need to remove a hash from the domain cookie. So cookie. So for now, these two I can pass right here. Replace and that one was 0. Yeah. So yeah, this method. So basically what we doing right here, so we are decrypting using the ASGCM. So this class ASGCM is used to decrypt the cookie using the extract tag IV and the subtext in the tag with the provide key. We need to now to remove the domain hash. So after the decryption, basically we need to call another method to remove any present domain hash that we have. So basically this function to remove the domain hash, so cookies may be they pretend as a SHA and 256 hash of the domain for security purpose. So these methods basically need to check if its domain hashes exist and beginning of the cookie, and just remove if the match. So you just identify the hash domain and compare the hash domain and remove if the hash match. So here I will create a remove cookie domain hash, and now I just pass the domain and the decrypted value, so the remove cookie. So essentially it's the same thing. Need to make the same. So just return the cookie because there's no match. var SHA264 for SHA4.create and void domain hash is equal SHA4.compute hash as encoding that you encode FO get bytes as domain. Oh, his hash match. basically it's different about the cookie. And basically this has match is equal false and break the loop. Yeah, so basically right here we just compare to the main hash of the cookie, and if we checks whether the first 32 bytes of the cookie matched the main hash, so if not, then there is okay and the match was not done. But if has a match, basically we need to remove the hash and remove the first 32 bytes from the cookie. And of course that we need to return to original cookie if it does not match or the original cookie was returned. So basically this has match, so byte as a final cookie, go on new byte as cookie dot length 2 and array b as a cookie 2 and a final cookie 0 and a final cookie dot length to the cookie and return a final cookie. So right here just return a cookie if that did not match anything. So by the final cookie, so just trying to return an encoding dot utf dot get string to the final cookie. Yeah, it's basically this is the function. So now I can just console.write line and pressing the host. Name. Make some pause in the video. Sorry, but yeah, actually the code was done. So basically you just need to compile and just going to a prompt and run the distiller and let's see how the cookies in the host, the cookie name and the encrypted value that it's possible to be used. So yep, basically it is. So thank you very much and see. Hello guys, today we're talking about JScript. It's a built-in functionality on Windows. Basically, first of all, I will attach some articles from Microsoft talking about JScript and unofficial documentations about JScript. So basically JScript is different from JavaScript because JScript is a Microsoft implementation of JavaScript language. It's based on ACMA script standard. So basically it's integrated on if Windows script host is they use H and using before for Internet Explorer. So basically initially it was more widely for used for task automations or administrative scripts or I don't know, interact with web pages before more and more the technologies become more popular. So yeah, basically we'll show something right here and how to use a JScript. So this is my JScript code that I have. Oh, right here it's a normal code into a JScript, so you can do a lot of functionalities right here. Interaction with internet or web services, etc. And right here it's basically the same script but with some obfuscations. And so yeah, in this example I will attach my JScript as a resource, so embedded into my loader. So it's a really not so common, but more advanced loader techniques to use built-in Windows functionality to download some files or get information on the internet, etc. So yeah, let's start with code. Yeah, basically you add a new resource file. And then you make import and filter for all files and get my JScript.js, and I call like lcdata. So basically this is my resource, and I will just change. So as you can see, my resource is already with my JScript, but I will change the ID for just 1 and save. So you can see, close and put my 1 ID right here. So yeah, let's start the code. So basically I make some includes again, like string, iString, another Windows.h, and also fstring for string manipulations. And so we make a main function, and the first step is to find the resource. So basically you have this directive using resource, and find the resource with a new model and make int resource, pass in my resource parameter or name, and sections rc data, but you could also create your own resource data. So yeah, basically as equal new, I just make an fail to locate resource, and just return and value. So can we compile to just test if the resource was found? And of course I need to turn something right here. Let me open my PowerShell. So yeah, the resource was found with success status. So basically now I need to load my resource, passing my no parameter in my h resource, and basically the same thing, but for you to load resource. And now we just make a lock resource to block for the all access, and passing my h data right here, and right here is just a pointer to void. And okay, so basically it's the first main structure. So the main idea is to get my JScript, create a file with JScript, and on the target host, of course, and start and executed my script from my loader. So now I can get something towards size of resource, passing no in my resource. Now I need to make data conversions, so I will use string directive, some script, and of course I need using reinterpreter cast as a char pointer to, oops, I press my insert button, fp data and my div size. So basically I need to convert all of the data of the resource, if it's a non-binary, to a string. So basically I assume this is a text file, so yeah, and now I can just print file content to my script. So you can also, it's not exactly a technique, but you can make some masquerade about printf or std count, std sur, etc. So it just to, so pstr to, I will call that as app name. So basically right here we need to pass to content from the JavaScript. So in this case I will put into 32 with a cscript.exe. So this is the interpreter for Windows scripts. So and right here I just create a constructor pointed to script, pointed to my script content. So the script.echo you see, so hello, just a hello, just something like that. Yeah, okay. And now I will create a temp file passing the max path, and if get temp path a, passing my max path and the temp file name, yeah, it's just temp file. And of course, if this equals 0, you can just copy and paste that pattern. So something like fail to get temp directory. And now the user start catch, passing my temp file name, and create a temp JS. It's a good one. So using something like start catch, or I need to use a secure warning, I guess, or warnings. I think it's just warnings. I don't. Yeah, I think it's this. So now we need to open the file to write the content. So basically I have I will create string a script file, passing my temp file, and if script file that is open, can just return another error. So error to open temp file, and now I can just script file, passing my script file, but close. So now I will pass the comment right here. This is the second part for my script. Send print is that one, I guess. Passing the comment, my size is a buffer, the size of count, and the format. Okay, something something like that. So right here is more, I think it's more difficult part, but I need to make some breaks to escape and print, of course. So something like this. Is that right? You guys know. And mass. Get out. Yeah, so I need to close that one right here. Oops. Yeah, that's right. Pass the app name and my temp file. So I think it's that right. Now I need to make a process information as a PI and my startup info A to get a structure. So I saw start info A. Startup. And so now we need to start a CScript interpreter. So if create process A and passing some parameters right here. So the first is the path for the application name. So just important is the command line, and the last two parameters is a startup info and the process information. So basically, can I just put new and on the rest? It's a bool, false, and the word 0, and provide no, and now I pass my structure to process information and startup information here. So now I just get that one, but I captured the get last error if something wrong has occurred. And of course it's a error on creating process. Yes sir. Turn 1. So can I just wait? So I pass in my each process and finish. So basically the main idea is that one, and I can just process finish. Can I close handles, of course, and PIH thread process and close handle pi.h thread. You can also delete the temporary file, but oops, it's not needed for now. Do remember that the function delete file is that one, and it's a temp file. So yeah, so deleted. and else fail to delete it. Just like this. So basically this is the idea. So let me compile. Cert CR security warnings on the top. And now I will just pass my, let me open my PowerShell and execute the function. So file content let me see what it's already creating the proxy. Yeah. Let me see, printf my content, file content. Yeah, this is not going to work. Let me see. Come on. See that what is wrong. So okay, this is the contents, but something's wrong when creating the process. It's a status error 2. Huh. So it's a no, my command, no, false. I think the pass parameters was right. So something's wrong with my command. So let me think. My app name is System32 CS script. Yeah, probably it's that one, because that part was right. Let's see. So this is my process executed. So I print more something to terminal. So hi JScript. Here's hello the test, and yep, this is my 2 PowerShells that I opened to the process into this code right here. So yeah, basically this is how to execute a JScript. So basically some secured solutions don't monitoring this execution. Probably some advanced solutions like UDR or something like that is you need to be more careful to execute them. But for and generally security solutions like an Avast, for example, with a premium that I have, they just ignore. So it's a really good technique. So thank you very much, and see you in the next one.